As usual, gonna wait 1 sec for Twitch to catch up. There we go. I should be live. Hello everyone, welcome back to the stream. We are currently in the middle of a refactor that I started a month ago at this point, but I haven't been able to stream for a while. What I'm currently doing is rewriting the analysis phase and splitting it into two phases, the name resolution phase and a type checking phase, the validation phase. Yesterday evening, I did an unplanned stream. We made a lot of progress, and I think I'm just gonna jump back in where we stopped yesterday. I was in the process of working on validating a struct expression, and that requires doing a tiny bit of type inference, and I wasn't entirely sure how to do that. Of course, I figured it out the second I closed the stream. That's how it always goes. But I'm just gonna go back to what I was doing. So yesterday I made the change to this type that I have that represents a type at the end of the type checking phase, which, you know, is one of the built-in types or some kind of enum or a struct or some kind of function. And I've changed it to have this type parameter there that is a functor that wraps the values of the types within the tree, basically. So here, if we have a struct, the struct type is also parameterized by the same functor f, and within the struct, the type of the fields are type tree of f, and type tree of f is something that wraps this type node within f. The trick is I'm using a type family here to basically, when it's identity, it just inlines. So in the case of type, the f parameter is identity, and in that case, then type tree is just a type node. There is no layer that wraps the thing. But for the others, we do wrap each type in the tree of types with something. For partial type, that is a maybe. And for this badly named thing that I'm going to rename as parameterized, at every level of the tree, we may either have an actual type or the name of a type parameter, basically. Now, with this, what can we do? The thing we're going to need to do is basically, when we validate a struct, I'm not sure if validate is the right term for this, because we're not doing any validation there. I guess we are, in the sense that we are checking that the thing actually maps to a struct. No, validate might be the correct word for this. What we're going to want to return is, okay, we have found a struct expression, and it contains, like, it might not have the full type information laid out. For instance, let me write an example of this. Something we might have is a struct S with like two arguments, T and U, that has a field X of type T and a field Y of type U, something like this, like a pair type. Let's name it pair for readability. Something like that. Now, we could have in a function or in a constant, X that happens to be a pair int, let's say, we could have something like pair and X is 0 and Y is 1. Something like that. Now here, for this struct expression, which is actually here because of a detail in the parser, we are not specifying the type of T and U, because those can be inferred from the values here. Those are ints, therefore we can do a mapping of what is T int, what is U int, and this is understood to be, okay, this pair here is a pair of integers. And then we can check that it matches what we have here. That is the very basic type inference we do. And to do that, we're going to need, when we find this pair thing, we have the name pair, but we don't have all of the arguments. We're going to need to return, okay, what type are we talking about? The base name is basically saying, where was that thing declared? What does it point to? What is the name of that thing? The list, and then we're going to have a hash map from identifier to partial type, which is going to be the arguments given here For instance, perhaps here we have int and underscore, and that means, okay, we're saying the type of t is int, and we're saying the type of view is a placeholder to be inferred. So here, the partial type would be int for t, but nothing for u, because we don't have a thing defined for it. And finally, we'll have parameterized type. For each of the fields, we will have the name of the field, as that is the information that we need about the struct, and we will have a parameterized type. For something a bit more complex, imagine a pair of int and int here, or something like this. Or rather, let's say here that this is that's an infinitely recursive thing. What example can I give to showcase what I mean? Let's say I have some struct foo, and this is a foo of u instead. And this parameterized thing will be something that is, okay, this is a foo, but one of the arguments is not a type, but this name u that we need to resolve, basically. So that will be what we need. From this, we will be able to do this build type parameter map. Hello, how are you? From this, we'll be able to do this type parameter map, which is going to be basically, okay, on the right-hand side, we have discovered that the type of the field in the argument is int. On the left-hand side, we have we know from the type declaration that it is a foo of u or whatever. Okay, foo of u, the actual type, we can do a mapping from the type name to the actual type that we infer from the expression. This is what this function does, basically. The last thing we'll have to do after that will be, okay, we have found a mapping for each letter. We have found a bunch of mappings for the different type parameters. Do they all agree? Do we have a mapping for each type parameter? And does it match with the template that was provided in the expression? So, for instance, like if I provide int here, does this template match what we actually found? This is, again, all things we had pre-refactor, but since the refactor has broken everything about this phase of the compiler, we have to rewrite it. So some of this work is already done. The build type parameter map is already done. We finished that yesterday evening. The only thing is, I think I still have the name holotype instead of parameterized type here, but otherwise that's all done. So this is just building, again, a association list of, for a given type parameter, here's the type we found in the actual expression. And we are going to need to build this validate struct that given just the name here that we have found, pair, that we know points to something, how do we resolve into, okay, the unique name that uniquely identifies the struct, and all of the other things that we require, again, the template for the type parameters and the actual field, the types of the fields that we have resolved. So let's get to it. I am not sure yet because I'm still mid-refactor, how we're going to handle type aliases at this point. Will they have been inlined by that point? I don't know yet. So since I don't know yet, for now, I'm going to leave this unimplemented until I think about it. For now, we're going to handle the case of a struct. The case of a struct is, okay, we have already done a name resolving phase, so we know that the name that we have points to a struct. This is the role thing that is now in resolved. There we go. So this is the thing that we associate with a given name as part of the resolution phase. Like we found pair. What is pair in this context? It could be a built-in type, a built-in function, a struct, an enum. It could be any of those things. Well, here in this validation type checking phase, we need to ensure that it is, in fact, a struct, or maybe a type alias that points to a struct. So this will be one of the very few cases that we actually allow. And here, so what we get is one simple thing, which is the base name. So we are going to need to go look at, okay, what information do we have about this base name in our cache from the previous phase. This will be, if I look at the monad that we have in our state, rather in the reader part of the state, we have this hash map from base name to the resolved definition, which is the output of the previous phase. Now, I'll probably want to do, since here, part of the reason why I'm doing this refactor and splitting the analysis phase into name resolving and validation is I want to have better types at the boundaries between each phase to reduce the number of times I have to do I have to report an internal compiler error because the state of my program doesn't match what I expect it to be. Here, I'm going to have one because I need to do this lookup. And if this lookup fails, that's not an error on the user. I've made it to this phase of the compiler. If this lookup fails, it means somehow I have resolved this to being a name for which I have no information. That's an internal compiler error. So I will probably want to introduce a new function. As part of the refactor, I've put all of the functions in this file. We will definitely change that and start putting them in different files as this grows. But I will definitely want to do a lookup definition function to avoid having to do the lookup in a bunch of different places, which is where I'll have the internal compiler error in case we try to do something that doesn't exist. So we are in some kind of monad M, and this constraint will be changed later to be some kind of monad diagnostic or whatever other constraint we require, including, again, being able to report errors. And our argument is going to be the base name, which, again, is basically something that uniquely identifies some declaration in the program. So module, unique identifier, that kind of thing. And the symbol name is base name plus the base names of all of the type arguments, or rather the full names of all the type arguments. So that's the logic behind this. That's the symbol name that uniquely identifies the thing. The output of this will be a validate in this monad underneath of, and here we will need a definition resolved. And this is going to be given some base name. We are going to be doing a view of the definition using the lens. And the function we apply on it is a lookup of the base name. If this gives me nothing, then we report an internal compiler error. This is validation. I probably want to change this error reporting thing to instead use the name of the function, but the stack trace should always be in there anyway. So maybe I'll remove that argument, but that's something we can do later. For now, this is validation definition lookup for the location. The error would be definition not found. And the details, we probably just want to include name, or rather base name. Name. There we go. So that's our lookup definition function. So if we go back here, I'm just gonna reduce this. We don't need all that screen space for it. In this case, we can get the definition with a lookup definition. Oh, I already have lookup constant. Oh, that's, yeah, that makes sense. Do I want to deduplicate those into, nah. Okay. We were here. So I look up the definition from the base name, and now I obtain what should be a struct definition, given that this was a struct. This is going to be yet another internal compiler error, if this definition is not the definition of a struct, because I said here that this was supposed to be a struct, I got something that is not a struct. I don't like this amount of internal compiler errors, which makes me think that there might be a way to persist that information in a better way. But that would be yet another refactor, and I don't want to like put more things on top of what I'm already doing, since I'm already basically breaking everything. So I think I'll accept for now that we might have some inconsistencies between the role here and the definition that we find. Of course, a better way to solve this would be to have the role here not just have the base name, but also have, the definition resolved or something like this. The only thing is, I am not sure we can do this. For structs, probably. But the problem is things like circular definitions, like function A that calls function B and function B that calls function A. For a function here, we can't point to the definition of something that we are currently in the process of defining. So we would have to have like not tying complications there. And I am not sure we can therefore like bundle the definition within the role. That would avoid the lookups, so that would be great. So that might be something to look into at a later point. But I would like to avoid the kind of like monad fix thing where we look into the future for where the result will be and put the pointer there. That kind of stuff gets complicated very quickly and can get hard to debug. So I would probably, for now at the very least, prefer having some internal compiler errors, but code that is a lot simpler, rather than doing this kind of like monad fix tricks for now. Again, we will probably want to revisit that at some point, because it would be better to not have a bunch of internal compiler error for things we have already checked. So here we have the definition, and we can, if I look at common, a definition will be one of those, and here I can do a very simple thing, which is going to be struct info is going to be the result of doing a case, which I guess I could actually just bundle that. This is a bind into a case. If we find a struct definition, that's perfect. That's the struct info right there, and we return the struct info. If we find literally anything else, unless we find a type alias, but again, I'm not sure about how I want to deal with type aliases, but even though we are in the case where it's a struct, so no, we should not be able to find anything else. This is an internal compiler error. This would be, and no, I'm gonna need, well, no, this is a path name. Okay. And except I probably want to actually include the definition in the error message. Just to help. So here, this would be, I'm gonna put this on a new line. The additional metadata we include for our internal compiler error, for our panic, will be what the role was and what the definition we found was. Okay. So here, when we reach this point, we have the definition and the struct info. So at the end, ultimately, what we will want to do, there's something wrong with this file since the indentation isn't working, so something in this file is broken. At the end, we will want the base name. We will want the parameters, and we will want the fields. So how do we get that? Can you just see if I can see where the problem is in terms of indentation? I don't. We'll see when I try to compile. Oh, case definition of. There we go. So for the parameters, this is going to be a matter of trying to resolve every argument that has been given, which is part of the path info here. If I look at path info, which at this point contains the role and the role of the arguments. So we're going to need to validate each argument as a partial type. It could be a type, it could be int, it could be character, it could be anything, or it could be something that contains underscores to indicate, this thing is a partially defined type, hence the partial type thing. So for the field, for the parameters, this is going to be, so we have a list of path info. So this is going to be for each of the path parameters, where we're going to get a... actually, no. This is going to be for zip, because we have the struct info as well. That gives us the number of identifiers. Oh, I should actually check here that the number of identifiers is correct. So, before I do any zip or anything, I will need to check that the number of arguments that was given was correct. So I'm going to just leave this here for now. We're going to go back to it. I've done such validation before. There we go. So let's go back to our struct, somewhere around here. There we go. So the way I was doing it before, in the pre-refactor version, if I go back to look at core and look for struct, there's a check struct function in this file. Or maybe it's in context, actually. It is indeed. What I was doing is basically, do we allow placeholders in this context? Since here I know I am looking, actually I might need to give that as an argument. We'll figure that out. I was doing the check here. Wait, no, that's in check struct type. It is in resolve struct type. No, it isn't here. Where is that? Oh, I guess we always allow the placeholder. Okay. So what I was saying here is basically... Wait, where's the check? Where's the check? Oh, is it part of the type resolution? It is part of the type resolution in the old code. There we go. So what I was saying is basically, if this is a place that doesn't allow placeholders, so all the types must be explicit, then the number of arguments must be exactly the number that is expected. However, if we are in a place where we allow placeholder, so underscore, so like please infer the type for me, basically, I was saying if arguments are given, the number must match, but they might also be not be given, basically. And I think I'm tempted to do something completely different in this new version. I think I'm tempted to say, since in this context we're allowing placeholders, I don't think there are contexts where I will need to do this kind of lookup where placeholders are not allowed. I think it's fine to do something where like, okay, any missing argument will be interpreted as placeholder. If you give 0, they're all interpreted as placeholder. If you only give 1, it matches the first one. I think that's a tiny bit more flexible So what we just need to do here, the only thing we need to check is that the number of arguments is less or equal than the length of the parameters. I might actually just decompose this as being a struct info, so I have access to the fields in scope directly. So that will be the length of the struct params. So if whenever the number of actual arguments is greater than the number of expected arguments, then we can throw an error incorrect type parameter count. Then what we can do is create the base mapping, which is going to be, so I have at the moment the path parameters, which is a list of those path info thing for each of the types. That is my actual path params there. And I will just need to create fake ones for the arguments that were not given. So this will be given parameters will be a zip of the struct params, which is the list of the identifiers, with the path params that were given to me, plus, I think cycle is the one I'm looking for. Let's open GHCI, import data dot list qualified as L. Is it cycle? No. Is it repeat? Yes, it is repeat. Repeat gives me an infinite list of whatever I give as an argument. So if I do repeat 3 or repeat the string placeholder, I'll get an infinite list. And if I take 10 of this, I'll get the 10 placeholder. So that we're going to want to do a repeat. And the path parameter that we will want to repeat indefinitely to be able to zip with the name of the identifiers will be this role that means we have not given the information, which is placeholder. So repeat placeholder. Now, we can do a for of the given parameters, and we will get for each parameter the parameter name and the given path, because at this point that is still a path, not, I guess it's a role at this point. Although at this point, yeah. The problem is by doing this, I have put a bunch of things in scope that are going to be a bit annoying here. We'll see. It is an infinite list. Well, this part is an infinite list, but we are zipping with this one, which is not an infinite list. So the result will be a list of tuple with elements of the first one matched with elements of the second one, the length of which will be the shortest of the two lists. So basically this will truncate this one to the length required to match this one. For instance, if I go back to here and I have this thing of like, I create this infinite here that is the repeat placeholder, which is an infinite list. If I try to do length of infinite, and I type it properly, this will never finish because, you know. But if I, oh no, please don't die on me. Oh no. Okay. This will come back at some point. But yes, if I zip it with something else, I might need to do a kill all GHCA quickly. Okay, let's kill this one quickly. Oh no. Okay. So let's go back to import data.list qualified as L. We make infinite, which is our repeat of the string placeholder. And now if I do a zip of A, B, C with my infinite list, the result will be a list of tuple A placeholder, B placeholder, C placeholder, because zip truncates to the shortest one. So here I'll have basically a mapping of the parameter name, the expected parameter name, to the given argument, or if the list of given arguments was shorter than the required amount, then placeholder. Now, I have given parameters is not a great name, but especially since I have parameters actually afterwards. Given mapping perhaps is a better name. That's the mapping we have. And given a parameter name and a role, what we're going to want to do is, since the output of this will be a hash map of identifier to partial type, we just want to basically translate this role, which is a path info here, into a parameterized type. No, sorry, a partial type. So, and I guess I can do this as a traverse 2, basically. A traverse 2 of validate partial type, which is a function we don't have yet, of the given mapping, which will apply this function that doesn't exist yet into each element within element within element. So in the right-hand side of the pair within the list, and bubble the surrounding functor all the way back to the top, which will give us in my monad a list of the tuple identifier and partial type. And at the end, we just need to make that into a hash map with a hash map from list. So that is our parameters sorted, provided that this function exists. It doesn't exist yet. We're going to do that next. So that's the parameters, to the point where I'm almost tempted to not use the given mapping thing and just give it as an argument here. That being said, it's not a bad idea to name things even if it's just naming them once. The fields will be, for the fields, this is going to be more complicated because for the struct, we have named values. Maybe I will want to change that to fields at some point. We have a non-empty list of the name of the field and the type, a type as it was defined. So here we will have something like this field is of type T, where T is a type parameter, or it will be a list of T or foo of T and U or something like this. And we will need to translate those into something. We will need to translate those into our new, how is it called? Not resolved, validated. Into our new parameterized type, in which the type at any point might just be a letter. This might require doing some substitution. No, I think we don't need substitution at this point, unless there are issues with type aliases. We'll see about that. So, given that we have, yes, no, common is what I want to have a look at. We have this non-empty list of identifier and path info, and what we want is a non-empty tuple identifier parameterized type. This is going to be kind of the same thing. This is going to be a traverse 2 of validate parameterized type, which doesn't exist yet either, of the struct values. Now, something I'm thinking about is theoretically, this could error, not in the internal compiler error sense, but in the user error sense. Like maybe the user gave a type that didn't exist or something like that. Well, we're past name resolving, so that feels. We're past name resolving, so all of the things here should be valid types. We've checked that they are. We validated the name. No, that's not true. We have validated that we could find the name. We have not validated that the name is a type. So perhaps the user gave a function name as a type parameter to as an argument to the thing. Like for instance, saying here, putting I don't know foo, which happens to be a function in scope, as an argument. That would be valid as far as the name resolving phase is concerned, but here in this validation phase, we should reject this. So this validate partial type function might throw an error, and not an internal compiler error, not a panic, but a recoverable one of like, no, here the user messed up. This program is not valid. Do we want to basically recover from the error here so that we can still try to validate the fields even if this failed? This might not be a bad idea to do that. And also the question I'm thinking about is, here I will be doing this for every time I encounter a struct expression, every time I call validate struct. That feels, I will want to cache this result. I will not want to do that every time. I will want to have a cache of like, no, for this struct base name, I have validated the fields and here are their parameterized types. Would that be? Give me one sec to think about this. Would that be a recursive validate thing? I think it might be. Rather than doing this in this case, I think this will instead be what the top level validate thing does in the case of a struct definition. And therefore, if we encounter a struct in a struct expression, we stack a analysis of a struct definition on top of the stack of things we're doing, which is we are using this to like be able to detect cycles in definitions when they are not allowed. So this is probably what validate the struct will do, and we can persist some of that information because here, if we go back here, this part makes sense in the context of like, oh, this expression must be a struct. Can we do all the type inference and stuff? This part makes no sense as far as like it makes sense. It can only needs to be done once. Basically, this is purely a matter of like computing it once. So do we need to persist that basically? I probably want to at some point. Yeah, I think I want to, because if I don't, then if there is something wrong in the definition of a struct, then every time we encounter that struct in an expression, we'll go through this, try to resolve the fields, and encounter an error, and the errors will not be duplicated. So this will need to be a recursive validate call where we put something on the stack, which of course does a lookup in a corresponding cache to avoid doing the thing more than once. That means we will want to persist something in the output of this that contains some specific information about the result of validating a struct beyond the resolving that we've done in the previous phase. Okay, let's go back to resolution. I'm curious to see in this split, what do we do in a struct? Yeah, we just resolve the path. We don't do anything more complicated than that. So we do need to check that we do have a type. Okay. So that means two things. That means here the struct info that we have, here, it is the input of our validation phase. It is not good enough. We will need to have something for the output of the validation phase. And I know currently I have a struct info there, but I haven't decided what should be in it, I think. I might not even have it. I do have a function info. I don't know if I have a struct info. I had to at some point, but I don't anymore. Okay, so I will need some kind of struct info that I will try at some point to deduplicate. So here, since I am, again, mid-refactor, the state of this thing is a mess, but the logic that I have is I am using a trees that grow approach. I have this AST representation, which for now has only one type family, which is name type. And a bunch of types, like statement and so on, are parameterized by a parameter that says which phase we are in. And in a few places, we use this thing for a mapping of like, actually in this phase, what is the type that we're using here? And for the past version of the AST, for instance, the name type is just a path. I will change this. It's going to be probably like a role type or something, but it is currently named name type. This is just a raw path. In the resolved version, where we've done all the name resolving, we now have a role instead. So I use this to basically keep a lot of the structure similar and just like switch what we branch to basically based on the phase. For now, since the validated thing is new, I have duplicated a bunch of things, partly because it will introduce a bunch of new things as well. But I will probably want to do the same thing and reuse some stuff. And maybe what I will want to do is, rather than have like a different struct info for the output of this phase, have a struct info parameterized by the new type parameter. Because I will want kind of the same information out of it. And instead, this will just be, rather than path info, it will be, I guess it will have to be one of those parameterized types. For now, the easiest thing to do, since I want to make progress, we will clean this in the second phase. I think I will want to just have a struct info version for this output that contains only what I need, which is identifier and parameterized type. Okay. That means also that we are going to need to keep a cache of this. We are going to need to keep do I? Because this is very, very similar. I was gonna say this is very similar to what a struct type is, but that's the fully resolved type. That is not what we want. This is a type information. This is an information mapping to a definition. Those two things are different. So no, I think we will need to have a cache of this. And I am tempted So the thing is, will we need the result of that thing in previous? We probably do. So basically, does that mean I need a cache of definition validated, basically? And I think the answer is yes. I've done something that I'm not super happy with, which is basically those caches, types, constant, types and constants, will be initialized as the things we already know about at the time where we compile this module. So all the things from dependencies, basically. It will probably make sense to do the same thing for the definition resolved as well. As in, have the cache that contains the things we have processed as part of this module, which happens to also be a cache of everything we know about. Now, the only thing I'm wondering is, do I want to split the cache rather than having, like I have here, a cache of definition? Do I want to have a cache of struct and enums, basically? A cache of the different definitions that I require, because that means if I have a cache hit, I don't have to then check that the cache contains what I want it to contain. Also because, will I need... Did I put the name validation of enums in the previous phase, or did I put it in this one? Let's look at enums. I think for enums I do nothing. Yeah, for enums I don't do any check. But those checks will be done. The checks will be done as part of this phase when creating the scope, something that I haven't done yet, I believe. Yes, the scope is assumed to already exist. I have not ported the functions that create the scope just yet. Okay. Also, no, I guess here in this phase, I do... checking of the names. I should probably do that kind of check on the enums as well, come to think of it. So I will probably want to do a resolve enum info here and add a resolve enum here, which takes as an argument an enum info pass and returns a resolve enum info resolve enum info. And I suppose actually for struct, do I... Interesting, I don't do any name validation on the name of a struct in a field in struct. So naming a field int in a struct would be valid as far as this is concerned. That's probably wrong. We probably want to check that. But do we want to check that at this point? Probably not, actually. This is purely the name resolving. And arguably, this validate here, validate binding, where do we use it? Binding. We used it for type parameters. Arguably could be done in the validation phase, given the name. Yeah, I'm leaning towards removing this and moving this to the next phase. So that will mean we will do that kind of validation. So that means that we can go back and remove resolve enum, because in this logic, there is indeed nothing to do at this point. There is no name to resolve. So this can go back to just being an enum def of the info, basically. Okay. So we will need to get so we will need to keep a cache. We'll need to keep some things about the then validated version of all of those types, because we're moving a lot of that validation to this phase. And I am tempted to split upside of splitting the cache, having a struct cache, an enum cache, having a cache per thing, is whenever I need to get specifically, this needs to be a struct, I want the struct there, please and thank you, I can do a lookup and I don't have to check that the thing within matches what I expect. But upside of having only one cache for this, for the types, is that in situations where I don't need to care what a thing is, I don't know if there will be a situation where I don't care what the thing is. I guess the upside is that the upside of having a single cache is that if I extend what kind of things we can define, I don't have to create a new cache for them at a later stage, basically. Ah. I am tempted to just split the validate state between things that are persisted, that are like basically part of the input and the output, and things that are local to the module, like global state, local state, kinda. Even though we need both, but if I do that, however, I will probably want to introduce lenses for each of the things manually. So maybe I'll just use comments for this. Okay. And so this will mean here that we will need either we do the single cache or we do the multiple cache approach. I am tempted to do like a cache per thing, basically. So this would be a struct that would contain a hash map from base name to what will be probably a definition validated. We will probably want to introduce the same kind of logic at some point, which will be the validated version that contains the information. Oh, sorry, that's for, so that for now that's going to be the output struct info, which at some point will probably be the same shared struct info, but with different type parameters. Because for enums, I don't need that. For enums, I can just check that they have been validated. There's no information that needs to be persisted in the output. So as long as they have been validated, a lookup here will be fine. And what kind of other types do we have if I look at the definitions? Type aliases should be ideally already completely inlined. Constants have their own caches, functions have their own caches, enum, yeah, okay. So let's do that. So we will have a struct info per struct, which means some of this will instead be a recursive call to ha. Ah, okay. My naming convention is biting me in the ass. This validate struct will not be okay. So this will be part of another family of functions, because validate will be the thing I use that I'm using at the top level for each thing I'm actually validating, like a function type, a function, and so on. So validate struct will be what we call here So I suppose that this will be more of a retrieve thing. Yeah, okay. So what I was trying to do will be more akin to a retrieve struct, or maybe validate struct expression or something like this. Okay. So let's rename this to, I think for now, struct expression. Although I think this is already part of, I already have a function named like this. Yeah. Let's think about it. Let's do things one step at a time. So I can move some of that code, but not all of it, as being the top level validate struct expression. That given a input struct info will perform an action in the validate monad that fills the cache. This is already using the validate here, so I'm already doing the check of cyclic definitions. I am already checking the cache for something that has already been validated. So this will only be performed if it hasn't been done yet, and will probably properly detect cycles. So if we have a struct A that depends on a struct B that depends on a struct A, no, I think it's fine. We will allow it. We'll need another mechanism for this. This cycle definition will not kick in. Okay, so here this is a case where we have the struct info. So we can remove all of this. We don't have the type checking. So the only thing that we have is we are going to have the fields, and the fields will be this traverse to thing. And at the end, when that's done, we get the base name from the current name. I need actually to fix validate function. And function type. Those will probably take types, not names. I'll have to fix that at some point. Okay, that's a problem for later. Wait, that's wrong. That's completely wrong. That's completely wrong, but we'll fix that when we get to it. I am going to move those two functions below here. Okay. So validating a struct will just be traversing with validate parameterized type the struct values. Then I get the base name from the current name in the scope. The actual name, this thing will be queued by, yeah, the constants are only using the base name, so I don't need to do that. I'm going to do the same thing here. The structs will be amended to insert for the base name a new struct info. Which will contain the struct parameters and the newly validated fields. There we go, which I could probably just inline here. Result doesn't add a lot of information. So that's validate struct, perfect. Which means I can introduce, in the same way that I have a retrieve constant here, I can do a retrieve struct, which will be lookup struct or attempt to validate. Looking up a struct will be looking at the VS struct and doing a lookup, uses the actual lens, not the field name. So we look at the structs that we have already validated and we just do a lookup. If it fails, we attempt to validate by looking at the definition. Which should always work. And here, for all three of those, I can use my lookup definition function I have introduced earlier. So I'm going to put that with the other lookup functions for whenever I start breaking this file into subfiles because it is way too big. So this is a lookup definition of the name of the base name. Do I want to do that as a retrieve definition to be consistent? Probably. Retrieve definition. Because lookup implies a possible failure, retrieve doesn't. This is retrieve definition of the base name. To the point where I am almost tempted to do this. Yep, there we go. And this is a lookup struct here. There we go. And type, I can do the same thing. I am not sure retrieve type will be able to exist the same way. Because I'm not sure retrieve type makes sense. because the type will only be added. This might not make sense. I'm gonna comment it out for now, and we will get there when we get there. Okay. Validate function type is also completely broken in its current state. So I'm actually just gonna, some of it is broken. I'm gonna make this unimplemented and comment it out. Validate function, however, is completely broken in its current state. Hence, for now, I'm gonna comment it out. So now we have validate const, validate struct, validate function type. I have this retrieve struct that will give me, this is the wrong type. This will give me a struct info, but the output version, which is what is in our cache. Now I can go below all of the expression stuff. And I can go back to what I was doing with the struct expression stuff. So when we have validate, where is it? Okay. So this will be the part where we try to, I'm probably gonna inline this then, because the other function doesn't make sense anymore. This one here doesn't make a lot of sense anymore. I'm just gonna copy paste it and put it back where it belongs. Okay. Except it might make sense in the context of, no, this is validating a struct expression. This is what it is. Although I might do the thing that I've done for some of the others, where the const version that takes care of a const expression delegates to a more generic function that can be used by both the const version and the non-const version. So let's do that. This will be a struct expression. Okay, so that will be, the type will remain the same. This logic will remain the same. And so this looks at the path name. In the case of type alias, if this can happen, we'll figure it out later. For now, we get the base name. All of this definition goes away. What we get instead what we get in, okay. If the lookup fails, it will report an error, which is fine. Yeah, okay, that's good. So here we can get our output struct info by doing a retrieve struct from the base name. There we go. And now we have the struct parameters that are coming from this. And for the fields, we don't have to do the validate parameterized type. We have that. That is already what this thing contains. So this is just here, the struct fields that are coming from, it's called values. Okay. So this will call recursively the validation, and now we need to do the validation of a struct, which we have already done, but except for one thing. We haven't done validate parameterized type, and we haven't done validate partial type. Those two things are missing. Okay. Is there anything else that's missing around here? So here, this will give me the struct base name, which I'm gonna here I'm gonna struct path, struct path. It's gonna give me the param mapping, and it's gonna give me the struct fields. And here we will need to create the struct type out of this and find a name for it. Okay. I suppose this might be where I'll have a cache of the name. Can I figure out the name from this? This is again something where this complicated system I've put for myself makes everything more complicated. I have at the moment, although this might change, a type thing that does a mapping from name to type. Type being this thing here that captures the type of something in the output. Maybe we don't want to do that. Maybe the type is something that's going to be decided every time, like every time we find a name, we're going to decide what the type is. Maybe this is not required. In fact, do I have at the moment, do I have a single use? I do put the function type in there, okay? So I do use it somewhere. Okay, I'm not gonna remove it just yet, but I suspect that this is wrong and doesn't need to exist. Okay. So if we go back to what we were doing, validate a struct expression, get the struct info, we do all of this. Then we have, okay. Do I want to do this first? Or do I want to do the validate partial type and validate parameterize type first? I think I want to do the type stuff first. So validate partial type is something that gets a path info resolved and returns a partial type. As in, this thing here, this path I have, I'm expecting this to be a type, but it might contain placeholders. That's valid. So that's going to be partial type on the path parameters as well. And then for the actual thing at the root that doesn't have parameters, oh, I should probably also check at this point. I should probably check at this point that the number of arguments is valid. I do that in every expression that calls something, like, oh, you're calling a function, you're calling a struct, the number of arguments must be valid. I I should probably do the same thing here. Give me one sec to think about this. I'm also trying to think of how do I avoid duplicating a lot of work between. Thank you. I'm trying to see how to avoid duplicating work between this validate type and validate partial type, which are going to do basically essentially the same thing. With a few, of course, key differences. Maybe what I'll do is do the same thing I have done for constants, which is to introduce a. I'm in the logic of like I would much rather have too many very small functions that have a very clear name rather than having big functions that do too many things. I might be tempted to do something like in the case where the thing is a built-in type, whatever the name actually is, do a validate built-in type that takes the name and the parameters. And do the exact same thing here, basically. That way, this code and the validation is moved to a separate function, validate built-in type, which takes, given some monad in which we are, which given some, the name here will just be an actual name, I believe. And given a list of arguments that have been resolved and therefore that are either types or partial types, which in this case doesn't matter, we will want to return in our validate monad the resulting but either type or partial type, and I don't know which one to return. I suspect here I can always return a type. No, I can always return a type node of f and let the caller decide what that should be based on the context. Okay? This will be, given the name and the parameters, a case of the name. And here, now, for now, those built-in types, none of them take any argument. So that's very simple. It's just reject parameters. However, for when we introduce arrays, this will be one of those where like, oh, for built-in type array, then we're expecting parameter to be one argument. And I think this is where we're going to do it. So this is going to be validate no params and something like this, and then return int type, basically. I never remember which is which. Import control applicative. What's the type of this one that I've used? I've used the wrong one. I meant this one. I always get them confused. So basically, do this action and then substitute the value inside with this one. And here, validate no params will be a very simple, I don't even need to do block, when length of params is greater than 0. And I'm gonna go look at the thing we wrote before. There we go. There we go. Oh, this is not a name, this is a role. I don't know. This will need... Actually, I could just do this thing where... No, I need to decide... Yeah, okay. I need to give the name as an argument. So that this error that requires the name knows what name to give here. So we were expecting 0, and we got length params. Okay. Okay. So that's validating a built-in type. We can use it in both of those functions. What is validating a struct type in this context? Is this the same thing? I think it's not exactly the same. I think there's some overlap with this, which is I think this becomes a validated struct type, basically, that does this. Although, does that require... I think it does. I think this is basically... Yeah, okay. I think this becomes... On the same logic of this, we have validate struct type that given some monad m and some, in this case, base name and some... Wait, I'm an idiot. No, this is indeed a name. It's this name here. So name needs not be given as an argument and needs not be given here. Here this is going to be given the base name of the struct and given the parameters t. Will I be able to do the same thing with partial? And this will require... Let's see. This is going to be likewise a type node of f. Or will this be actually... This is probably going to be a struct type. Here we're going to, oops, copy. Let me put some more space. The thing we have copied, there we go, from the previous function. So we are trying to get a struct type in the output, which is validated. It is this thing. Is that... Am I duplicating work there? I am, and that's fine. I am, and that's fine. Okay. So this is going to likewise be parameterized by f, which we're going to figure out. And I suppose the types can be, since I have f as an argument, this is a list of types that have been resolved. Those are type node, type tree of f, actually. Okay. So here we retrieve the struct from the base name, which does all the check, potentially validates the thing. We look at here, so I have the parameters, which are those, the actual. I look at the expected, which is the length of the struct parameters, and if it's wrong, I throw an error, which is the same logic that we do here. What do we return here? We need the name, and we need the fields. So the name will come from those, which have been resolved. I can't create a name at this stage. Ah, okay. I can create a name when I'm doing... I can create a name when I'm validating a type because I have all of the information and the name must contain all of the information. When I'm doing a partial type, I cannot. That's the whole thing, is I cannot validate that the thing is a name. So what does it mean to do validation of a partial type then? How much of this can I do? Can I do this work? Can I use this logic for both functions that validate a type and validate a partial type? I think I cannot. Unless I... no, because I do the thing with the HKT to try to erase identity. I was going to say, do I have a way to combine within the functor, and therefore if any of them is wrong, then none of them exist? That makes no sense for the type parameters. It doesn't work with identity. That doesn't work. Hmm. But the problem doesn't come from this. The problem comes from this. No, from this. Where here in the struct type, I'm requiring the name, which is something that I don't have. That I don't have if I am not in the case of a type, if I'm in the case of a maybe type or something, of a partial type. One solution would be to put that in F as well. With the idea being, okay, when I have a type, F of name is just name. I have the name of the thing that is associated with it. The other option being I remove the name altogether. Why do I keep the name in the type annotations? Can I remove it? I don't think I can. I don't think I can. For the process of lowering into IR, I will need to be able to point at type definitions. So I will need to know the name of a given type based on the type annotation. So I need to have the name in the type annotation. I think that's unavoidable. However, this breaks this design of having the partial type with and the parameterized type with a functor, Because for those, the name doesn't exist, is the thing. Unless, unless name is parameterized by f in the same way to allow for the same kind of ambiguity. But is that too complicated? Okay, I'll have to think about this. Because I think, yes, I want the name. I think I want to be able to say, oh, here's the struct information, but also here's the name for the duplication, the unique name of that thing, especially depending on like the different kind of backends. If I do something that exports hello, if I export to like the LLVMIR, I will need to know, oh, this type annotation, here's the information, but here's the actual type it points to. So I will need the name. But what sense does this make when I have a partial type where I might not have the thing? Well, I suppose I have the name when I do have a yeah, but I don't have its type. Yeah, no, this makes no sense. Okay, so this means this logic here doesn't work as it is. We're gonna need to go back to it. We're gonna need to think about something else because this breaks the validate partial type thing. I can't create a partial type because I can't create the name because I need to do all of this first to be able to have the name of the struct. So, what do I do? Since I am not sure how to solve this conundrum right now, I might choose to instead work on something else. I could continue some of the work on the expressions. I could go back to some of the work I need on the diagnostic stuff that I have removed at the moment. I could do either of those. I'm gonna give myself 5 minutes to go get a drink and think about this, and I'll be back in less than 5 minutes, and I'll probably just switch to something else. Be right back. Okay. Drink acquired. Yeah, I have some weird like circular thing between name and type that I'm gonna have to figure out. So since I am not sure about how to do this, and therefore how to do the type inference, let's see where I am using validate type so far, actually. Okay, so here I am doing validate type to get the type of a constant. That makes sense. It cannot be a partial type or anything like this, so it must contain. Okay, that makes sense. And for struct, I do validate parameterized type on the fields. That makes sense. For a cast expression, it must always be a type. Yeah, sorry, that was. I said 5 minutes, but I didn't actually need five. So all of those are just like, okay, I need to obtain the actual underlying type for this, which makes sense. Let's think about what a struct type would be in this context. So in the case of validate type, where I am not in the partial case or anything like this, for a struct, it would be So in the case where here I have type and I'm returning a struct type of identity. So the actual struct type with the name. What would I do in this function? I would retrieve the struct info that gives me the parameterized types. And I would need to assert, oh, wait, isn't this just... Isn't this just what I'm trying to do with the whole validate struct thing? Isn't this just that? This is... I know the type parameters. Well, no, because in this context... No, I have the parameters here. I have the parameters, so I should be able... This is what I'm trying to do. This is what I've been trying to do with the struct const expression thing. With this function, this is what I've been trying to do. Where here I have this thing of like, okay, I am making a mapping of... So this is what I've been trying to do here, in a sense. This is creating a name that matches. So that makes sense. Here in the context of a type, what we do is we have checked that every argument is a type. We have checked that the number of argument is correct. Aha, but here, when I'm validating a type, an actual type, aha, that is, I think, an answer. When I'm validating an actual type versus when I'm validating a partial type, those things are different. That means I'm not necessarily doing the same thing when I'm validating a partial type that when I'm validating an actual type. Okay. That's interesting. So that means that we can probably write some of validate type. The only problem is the name. The only problem is the name, and I really need to think about what that means. Does a possible solution that I don't like, but that will work, maybe that's the right approach, is to use another parameter, which is, A, what kind of name are we storing for this particular thing? We make that a parameter. Function archetype requires it as well, because type tree here requires it. So now we've added a type parameter for the name. And as far as a type is concerned, yeah, we want the name. It makes sense. The type at the end must contain that. As far as partial types are concerned, unit. We don't have a name at that point. That's the whole thing. And therefore, that way, we don't have to try to store something that makes no sense. This feels a bit inelegant. We have, at this point, we've basically duplicated, like, we are avoiding duplicating this 3 times, basically. but we are adding more and more exceptions. Is it worth it? I think this is okay. Okay. So with this, we've probably solved our problem, and we can probably go back to what we were doing. So validate built-in type can remain the same because this does not depend on either f or n, so we good. So when we validate the built-in type here, we obtain the result we're good. That's perfect. That's a type. Here, we will need to wrap this into, since it's a partial type, we will need to wrap this into a just. Okay. For struct, this thing I'm writing here will have to be different based on whether we're doing an actual type or a partial type. Here, there's going to be some duplication. I think that's fine. Especially since, anyway, the check here will have to be different in those two cases. In a case of a type, actual type, real concrete type, this could be called, actually, I'm going to name this concrete type to be very explicit. In the case of a concrete type, the number of arguments must be exactly the number of expected arguments. It cannot be anything else. And when we return this, we can. So here we will have the parameters will be a list of actual concrete types. We have the base name. We should be able to create the name. Validated. Look at the struct type. So we need to create the name, and the fields will be. Aha. So I will still need to do type substitution. I will need to do type substitution, but that's not a problem. Okay, in which order do I want to do this? There's so many things we have to do. I need to write type substitution. I need to write getting name from a type that is already known. Which order do I do that? I might start with type to name. So that's going to be somewhere around here. Again, we're going to clean this a tiny bit later. This will be get type name. So given some type, give me the corresponding name. And get type name is just a case of if it's, and I'm going to just kind of copy and paste this. Aha, but function type doesn't have a name. I don't have a unique name for function types. So this is going to be a maybe name then. Until we are able to give unique names to function types. And so int, if it's an int type, it's an int name. If it's a Boolean type, it's a Boolean name. Those are easy. If it's an enum type of a name and some identifiers, that's the name. If it's a struct type, it is the struct name. And in all of those cases, it's going to be just the value because we are returning a may b. And for a function type, that is nothing. Function types do not point to a specific name. No, maybe I don't want to align this. Okay. And of course, this is just that. Okay, so get type name is fairly straightforward. Now, we're going to need to do type substitution. It probably doesn't belong in this file, but that's fine. We will fix that at some point. So substitute types. Oh, there's already something named substitute types. I want to do a git grep. There we go. Substitute types. It's probably in the old files. Yeah, okay. That being said, I can probably copy the old function and adjust it. It was in instantiation. There we go. This, although this is going to be very different, it will look, yeah, it will look very similar. So get back to it. Substitute types. So we will have, instead of having, we will have a hash map from identifier to type, which is the type parameters. We will have a parameterized type that contains sometimes a name of an identifier, a name of a parameter instead of a value, and the result will be a type. So this will be a very basic case of what is a parameterized type. It can be left of an identifier, in which case it is that. I do a lookup default with this error if we cannot find it. Except this is not generic function institution, this is just type reification, I suppose. But that should never happen. And we have all of the other cases that we're going to list, and those cases are all of those possible values. And this is going to be if we have a parameterized int type that is just an int, that becomes just a int. So this is just extracting the thing, basically. For an enum name values, this is, did I name n? Oh yes, because of course this is a type. That just becomes likewise enum type name values. That doesn't change. I can't just like say like take this value and use like name it x and put the x here because those have different types. This is a type, this is a parameterized type. So I sadly cannot just take like, oh, this x is the same x here. I have to deconstruct and reconstruct. And here, if I have a struct type, oh, I have a problem. I have a small problem, which is that struct type is a constructor in this, and it is a constructor in this, in the same way that function type is here as well. Let's continue with the same naming logic. This is a function type info, which is how I've named all of the struct that contain additional information for a given constructor. There we go, fixed. So here, if I have struct type that contains some struct info, here this is just gonna be going through we have the name problem again. Here I need to create a name for the struct. And the only way to, I can probably create a name for the struct. Okay, but this is going to be complicated, but I can do it, I think. I'm just going to introduce a new local function for this, I think. So this is going to be substitute struct type. Yeah, I think I'm going to call this refi type, actually. It is, in fact, a form of substitution, but we are also doing the name thing. So I'm going to do this like this. And for a function type, what do we have in a function type? We have the arguments that contain things. Yeah, okay, but it is a lot easier, but nonetheless, we need to do that. So I have a function type with a function info here. Function type info, technically. In this case, we're going to do a substitute function type of the function info, and here this is going to be wrapped back into a struct type, and here this is going to be wrapped back into a function type. Okay. What does it mean to do a substitute? Let's do the easy one first. Function type. We're going to get one of those function type info as an argument. And we're going to create a new one as a result. And the one we're going to create, which is going to be slightly different because this type is parameterized by those two things. And we are going from we have either and unit to we have identity and name, basically. We are going to go from this one to this one. And okay, so this is going to be the fun args are going to be a map refi. Let's be consistent. Map refi function arg of the fun args that are coming from here. And the return value, the reified version, will be we have a maybe of a type. This will be fmap. I'm not going to use fmap for both, just for symmetry. And this is going to be refi type of the fun return. Okay. What is refi function arg? Is going to be a simple case of was this something given by value or by reference? If it's by value and it's a type, it's going to be, the result will be by value of refi the type. And if it's by reference, of a type, it will be by reference of reify of the type. Okay. And last but not least, what is reify a struct type? This is the complicated one. This is where everything we've done so far has been. This is the big problem we've had so far, basically. Actually, since I've done an indentation here, I'm going to indent all of those. For consistency, and to avoid having lines that are too long. This one is already a bit too long. 73, not too bad. So here we have the struct type info. And likewise, we are going to create a new struct type info. That's our goal. The big issue is here we're going to need the struct name. And that's tricky. And we're going to need the struct fields. Struct fields will be this non-empty, okay? So this is going to be basically a double F map of the reify type. Oh, actually, I should... when I do a reify type, I need to pass the mappings recursively. I'm almost tempted to make a go function for the recursion. I think this is fine. Okay, so the fields will just be an fmap2 of reify type with the mappings of the struct field. But the name is where this is going to get complicated. I will need the base name for this. There we go. That is a much better solution. Base name. That's a lot better. We keep the base name around, which we're gonna need at some point. And here we have the base name. We can make the full name. So let fields equals this. I have my list, my non-empty list of tuple of identifier and types. Oh, wait, that's slightly different. Here I need the arguments. God damn it. I know what the arguments are because I have the mapping here. So as long as I have done the proper substitution before, I have a struct type that only contains types that come from this, which means I can obtain types for all the fields. But to obtain the name, I need to know the arguments to... So I need to look up the definition, basically. I need to look up the definition, or I need that information to be persisted as part of the struct type info. Because the whole point of name is that it encodes, it uniquely identifies the struct. Huh. I think then that I have what I was saying earlier was actually the right approach. Rather than doing this, rather than doing this thing, I replicate this logic for names. Which means here, rather than having a name, I have a name tree of f. Which means, in the case of a struct, I will have a partial name or a parameterized name, depending on whether I have a partial type or a parameterized type. That's the only thing I will be able to then reconstruct into a type at the end, or a name in this case. So this will be a name tree of f, and as an argument disappears. I wanted to avoid that, but I think that's the unescapable conclusion. Okay. This remains, I think. Although I guess I could generalize it to being given some type node. No, I'm gonna keep it as type for now. I don't think I will actually need that for other things. Okay, so that means we go back to name. This is why this refactor has been such a colossal change, is I broke everything and I'm not even in a state where I can compile the things at any point. This is a bit tricky, but it is fun. So name becomes the name tree of f, which is something that has a base name, and rather than having names, it has f of name tree of f. Here, I don't need the root to be, because I always want to have a base name. Here, the root might not exist. Actually, maybe I don't want that. Maybe when I want the partial types, I want the root to be known. That's not true. That's not true. For a partial type, I want the root to be known, I think. But for a parameterized type, I don't. So actually, this is a type node, maybe, for the partial type. Okay, but here for name, I never want the base name to be not known. So I think I don't need this type tree intermediary thing. Here, I'm going to do the same thing. I'm going to use HKT here to remove this when it's identity. And I can use this thing, same logic here. Name, I'm just going to rename this from type to name. A name is a name tree using identity. Partial name is a name tree using maybe. Parameterized name is a name tree using either of identifier as the functor. Okay. Just need to copy this into this. This is probably gonna work. That's fine. Okay. What else do we need? I think with this, we can go back to what we were doing in here. So when we reify the type, here we have a partial name. So I think fields can go back to being here. The struct name that we have in input is a partial name, is a parameterized name. So what we need to do is go find a name for all of them. So this is basically a refi name using those mappings of the struct name. And refi name, oh, oops, there's already a function here. Refi name, which will probably just a helper function as part of this, will be something that, given the mappings, and a parameterized name, will give me a name. And so, given a name tree that contains a base name and the arguments, the params, excuse me, the result will be a name tree, likewise, in which is it called name underscore base? It's called name underscore base, in which the name underscore base will be unchanged because that's not something that depends on the type there. And what's gonna change here is going to be the name params. What I'm gonna do for each of them is just go on all of them, where go, it's going to be a function that does a case. In the case of left of an identifier, we return, yeah, I'm just gonna inline this function in this because it does the same stuff and it requires the same access to this thing here. I'm gonna just look up parameter identifier here and look up, so here there's going to be also just lookup parameter of the identifier. Lookup parameter of an identifier is going to be this. Except I'm going to rewrite it as being a lookup of identifier in the mappings, and on nothing report an internal compiler error. Okay. So here I could almost inline this back now, but it's fine, I think. What's the longest it would be? 84. Yeah, no, I'm gonna inline it back. So here either we have a name, we do a lookup parameter, we get a type, and then we do a get type name. And here I suspect that since function types are a special case that for now we don't handle, since they can't be declared at all, I think here I'm just going to say this can't happen, therefore I can always reify the thing. I'm tempted as a result. Since function types will always be concrete, they cannot exist in the state of being partial. No, they cannot. That makes no sense. in the current version of the code, I think for now I'm just gonna do something slightly inelegant. And get type name is just give me a name. And in the case of function type, this is going to be a internal compiler error because this is impossible in the current state of the code. Yeah, the name here, I don't know the context. I should remove this name with just the function. So gate type name, I suppose, but I'll change that at some point. Except, there will be places in the code where I'll be like, oh, can I make this into a name? And for function name I can't. So I think, no, I'm going to keep this way. This function here in this module is not aware of the fact that there are places which makes no sense. Keep the maybe name. And in the process of the validation, expect name takes a type, returns a name. Expect name is given some type t is just get type name on nothing report ice. Yep. Which means here I can just do an expect name that, and it will always succeed. Well, it will panic if it doesn't, but that's a case that's never supposed to happen. And if we have something that is the right-hand side, the right, that means we have something that is actually another name tree. And that's what we do in that case is just reify name of that name tree. There we go. Which I think, if I go back to HKT, a lot of those functions are probably equivalent to just an f apply or something like this. I could probably rewrite some of this. I could probably rewrite some of this as just like given a function from one to the other, do something that like traverses the whole thing. I don't need to worry about this for now. Okay. So now I think we have everything. For all of those cases, it's trivial. And then when we have a struct, technically I will need to reify the name there. That name for a type will technically be I'm not gonna bother. I'm gonna here. I don't need to make this more generic than it needs to. I know that an enum never takes arguments. An enum name is just always the base name. I could even put base name here, to be honest. Like, yeah. So since there's never any need for more, here I don't need to do any reification. That's only needed for the struct. To know where, to what declaration we're pointing to, basically. Okay. So now we've done the type reification. Let's reread it to be sure. For all of those basic type, if we don't have a type, we do a lookup. If we do have a built-in type, it's just that. There's nothing complicated. Enum, likewise. functions we have to do. I'm not sure it makes sense. I don't think it makes sense to do reification of function types, but we might as well do it. And for struct, which is the case that we really care about, because it's the case that started all of this mess. I have a nested where. I'm probably going to want to change that. This is going to be... Yep, there we go. So for a struct, we reify the name, which is this thing. Yeah, okay, that should be fine. Perfect. With that done, we can go back to validate type and validate partial type. In the case of a validate type, I need to have, when I try to validate a struct, I will be giving likewise the base name and the params. It's Emacs. It's the same Emacs configuration I've been using for probably close to 20 years at this point. Well, for Haskell, no, because I've only been doing Haskell for a decade at this point, but So validating the struct type will be this thing. We retrieve the struct definition. Because, okay, so what we're doing here, this function is, we have found a path info resolved. So there was a path in the code, foo, somewhere. We, as part of the name resolution thing, we have decided, hey, this thing actually is a struct. Now we're trying to say, okay, well, we know that this thing foo in the code points to a struct. Can we get the fully resolved type and validated type information? So what we need to do is get the definition from the name that we have found that this thing points to. For instance, this thing foo in the code points to a.b.foo that is imported through another module. So now we retrieve the definition of this foo thing that we're pointing to, which is what the retrieve struct thing here does. And it gives us the validated definition where we have checked that the fields make sense and we have obtained the types of the fields. Okay. Now, we have the type arguments. Since we are in the context of a concrete type, we have used this validate concrete type on all of the arguments. So all of the arguments must be known. And we have a list of types. We have checked that we have all of the type arguments for the struct. What we will need to build here is one of those struct type kind of thing. Struct type info. So I'm going to copy this. This is what we want to return ultimately. We want to return a struct info with that kind of information in it. The name will have to be obtained. So the name is going to be fairly easy to do. I'm going to introduce the same way that I have a concrete name thing. I'm going to change concrete name to be something that given But that's gonna create a no, I can't do that. It's gonna create a circular dependency. I don't want to do that. Okay, that's fine. So the name is gonna be, the constructor is called name tree, which is unfortunate, but that's what it is. Where the base name is the base name, and the name of the arguments is map expect name on the parameters. Okay. And the fields, I have now, thanks to this struct info, I have the struct fields. And I think this is exactly that. This is a fmap to a verify type of the mappings on the struct fields, but I will need to create the mappings. And in this context, I know that the number of arguments actually equals expected. So here, the mappings is just a hash map made from a list obtained by zipping the name of the arguments with their types. So that gives us the actual type and the unique name associated with it for a given struct. I should continue doing the enum and so on for some of those, but what I want to do is see now how this works for validate partial type, where some of this will be the same, built-in type doesn't have to change. How do we validate a struct here? I'm gonna copy what I have here. And sadly, there's a bit of duplication, but it's unavoidable because when we are validating a partial type, we don't have all of the information. That makes sense. The thing that bothers me is that we're gonna have the third version, which is parameterized type, which is gonna be very, very similar. And maybe I'll try to see if I can deduplicate things. But for now, those are gonna be different enough that it's worth doing this way. So here I do the same thing. Have the check here is different. In the case of a partial type, it is fine for the number of actual arguments to be lesser than the number of expected arguments. That is fine. That's the whole thing of partial types. So the only error is when actual is greater than expected. That's when we have an error. So that kind of stuff is why having duplication is good, is because there are some subtle differences here depending on what we're trying to do. Here, then, the mapping for the names becomes... So my struct params here, since those are partial types, no, okay, I'm gonna change something. In validated, I have said that like the root cannot be a no, I want to keep this. The root cannot be a maybe. So the root is not wrapped in the functor. So that means that in here I will need to have some kind of go function where I do the thing. So this one, I suppose, that allows for I will need to allow placeholders for the parameters and their own parameters, but not at the root level when I do a validate partial type, because the root must be a known quantity. I suppose I can just have the whole function recursive function always return a maybe, and if I am at the top level, like just expect it to never be a maybe, because since I have a value, yeah, no, I can do that. Yeah, I think that's the best solution. So this will be go. And so given a path, this is going to be go of the path. And on nothing m, if this gives me nothing, this will be not an internal compiler but an error, which will be something. I don't think I have an error for this yet. Diagnostic, placeholder. I have an error placeholder that might be good enough for now. Placeholder at root or something like this. I will probably want to have a better diagnostic than this. But basically, I'm trying to resolve a partial type, so a struct of which the type parameters are not known, or an int or something like this, and I found placeholder. That's invalid. So the root cannot be a nothing. Okay. And then the where block starts here, and go of some path info is gonna be this thing that I have here. And I validate things recursively with this go function itself. There we go. Okay. The whole point of this is that placeholder is valid. I'm gonna group the ones that make sense and the ones that don't. Placeholder is valid and gives me pure nothing. Okay. Now, to validate a struct type, so I retrieve the struct, I do the same thing. I check. Okay, so this is where I'm gonna go back and take the thing I was doing, and this, I'm gonna do this thing. I'm gonna do it back here. Because the mappings are gonna be slightly different. The mappings of the type of the parameters will be zipping the struct params likewise, but with the path parameters plus repeat placeholders, since we are allowing the number of arguments to be lesser than the number of things that are expected. And this is an output placeholder. Wait. Wait. Placeholder makes no sense. This is not repeat nothing. Because I'm creating a partial type, and the whole thing of a partial type is there's no thing as placeholder. I have maybe an actual type, and if I don't have something, that means it is nothing. So repeat nothing. Okay. And to create the struct type info, the name, which is a partial name, will be, since it's a partial name, that means the values will be maybe values. So this is an fmap2, basically. If there is a type and it's not nothing, then do an expect name on it. That doesn't work. I'm going to need to do an expect partial name or something like this. Why is it so complicated? But it's going to be something along those lines. Expect partial name. And the fields are going to be something similar. Ah, maybe this changes a few things, I suppose. What does that mean here? I think this is not useful. It's required for the type system, but I think this holds no value for us. This is basically the list of type of the fields, but for all the types that are missing, I'm just gonna say I don't know. Well, no. This is important. This is actually important. I'm wrong. I will need to do the substitution with what I have found, I think. So, give me one sec. I know what to do here for this to be valid from a type perspective. From a logic perspective, I think it is actually not useful. Because this is just saying I want some maybe empty types. Yeah, that's just. It's not. It's not useless. I can use this for better. Do use this for better validation later on. Okay. So this is basically the same thing here. It's refi type mappings on the struct field. The only thing is I will probably want to change refi type. Where is that one again? To take huh. Yeah, this takes some kind of type T and returns some kind of type T, I suppose. The only problem is here, how do I put this into the functor? Do I have something in my HKT module for this? I do have an H pure. Perfect. So this is H pure. So this requires. So this is not just T. This is a type tree of F, where F is an applicative. It needs to be an applicative so that I have pure. And I return a type tree of F. And now I can use H pure to put something in F regardless of what it is. Even if it doesn't exist, because I do identity elision. Okay. Okay, perfect. And in this case here, we do a lookup, we obtain a value, perfect. So the verify type can be done for partial types as well. No, okay, it works. Parameterized type is hard-coded to be left or right, perfect. This doesn't change. This doesn't change. This changes. This is refi type mappings. It doesn't change. It was wrong. That's different. Okay. And now expect name, refi name. I'm gonna have to do the same thing where I'm gonna have to make this be parameterized over Okay. So what does that mean? That means expect name becomes, rather than from type to name, it becomes from time tree of f to name tree of f. That's correct? I think that's technically correct in the sense of that that's what we needed to be for it to work for both partial type and for type. But I don't know if we can write a generic function like this because of the root problem. I could potentially do this. That is possible, I think. But that's not what I want, I think. I kind of want this to be a type node, because that would allow me to do this, I think. The problem is in the context where this is a partial type. In the context where this is a partial type, it could not exist. That is the problem. Oh, I suppose then I can do an HF map or something like this. H map. Yes, I can do an H map of expect name into this thing. Yeah, that works. And now expect name can be like this. Okay. Okay. And I think then that means that this expect name will be moved. Well, it's already in type. Perfect. This will need to be changed to be for a type node of f becomes a maybe name tree of f. And I'm tempted for consistency. Do I want to change name the names of tree and node to be consistent? Uh, I'll make it work. I'll clean it later. Where this remains the same, but the difference is this is an applicative. So I can do just h pure of this thing. I'm gonna start doing this for readability. And this is just h pure of the struct name. And this is the nothing case. Okay. And here, as a result, expect name should now be generic, which means each should work in this context here. Okay. And now we have made reify type work for any kind of type destination. Perfect. Which means that when I validate struct type in the context of a partial type, I can do reify type with the mappings the same way, and I will get the substituted version. Okay. Okay. Whew. For an enum, it's gonna be. I think at this point I probably want to take a break from doing those functions, even though there's more to do, like validating an enum and so on. And I still have to figure out what I want to do with. I still have to figure out what I want to do with type parameters, because there will be places where I find type parameters. I must know what they are in this context, but that requires doing a lookup in the current context and so on. I will need to figure out, like, I need to write for the enums and so on. So there's a bunch of things. I don't know exactly how type aliases are going to work with this new approach yet. There's more that I need to figure out for those things. But this should give me enough that I can go back to what I was doing and finish solving what I started with, which was, again, the type inference of struct expressions, where I have something like this. I'm creating a pair, and I'm not giving type arguments, but the type arguments can be deduced from the things. That's what I'm trying to do. So if I go back to validate struct expression, that's the thing. I think this whole function goes entirely away. Not entirely. I still need the parameterized types, I think. Which are no longer part. Which I don't have. Okay. So, this almost all entirely goes away. Because this becomes a validate partial type of the path info. That's the function we've just written. It gives me a partial type. So unless I have made a mistake, no, it is indeed one of those things. And since I'm trying to get a struct, I want that to be I want to check that indeed what I have is a struct type, and I will get the struct type info that will contain, at the very least, the base name, from which I can go get the definition again. Unless I figure out that I probably want to keep. Do I want to keep a copy of the definition in this so that I don't have to do a lookup of the base name again, basically, since I've already done it? Because this contains the replaced fields, where, like, okay, this struct has its type. If I go back to here, where's an example that I have left in the code? There we go. After I've done the get partial type, I get the type of the fields after doing the replacement. So if I have given nothing, all the things will be replaced with just the placeholder, so nothing. At the end, I want the type to reflect the actual thing, so contain int and int, but I still kind of want to have the parameterized version around that I will need from the definition. So maybe to avoid doing extra lookups, I might want to add the raw fields, which is basically the same thing, but here, rather than having a type tree, I have a parameterized type. That is the thing I am caching from the definition. This is a bit redundant, but this means that once I have solved the type, I have obtained the information, it is cached and I don't have to do additional lookups, which I think is worth it. That means we go back to validate struct type, and again, so here, the raw fields are just the unmodified struct fields that we obtained from the definition and that we are caching to have access to afterwards. The same thing is done here in the context of a partial type, because likewise we need to have access to that. And that means that when we do the build type parameter, the reify type thing here, we need to forward the struct raw fields as just being they're going to be the same in this case, but I guess I can just use the raw fields. Okay. Now that we have this, we can do the thing that we started with this evening almost 3 hours ago, which is that this entire function no longer needs to exist. The only thing I need to do is validate partial type. And I'm just actually probably gonna introduce a function for this. Validate struct type here, which is gonna be I validate the partial type, which gives me a partial type. And I can do a case of this partial type, so I can just do that into a case. And if I found that this partial type is a struct, that's perfect. That's exactly what we wanted. Struct type. I have therefore a struct type info with all the things I want. And I can return pure of basically this base name parameters struct value. And I don't know if I even need the base. I will need the base name, yeah. Yeah, because the base name and parameters, that's just the name. So I guess I just need the entire struct type info. That's what I need. So I just return the info. And if I have literally anything else of a type, that's not an internal compiler error. That's a perfectly normal user error. Report, not a struct. I was looking for a struct and I got some other type. I got an int, I got a character, I got whatever, I got an enum, I got something else. This other type is not a struct. And all of this goes away. And this function becomes give me the struct type, which is doing a partial type of the thing and then checking that it is indeed a struct, and not just any arbitrary struct type. Then validate the fields, which are constant expressions. And this is now a struct type info. And what we need to do now is finish the type inference. And finishing the type inference means, okay, we have the type of the fields, we have the expected types. So what we can do is, and I don't think I'm going to copy the old code for this just because it's so different that it's better to just redo it manually. Okay, so we are going to want to do some type mappings. Because I have this build type parameter map function that, given a parameterized type, a type that contains type parameters, and some actual concrete type, gives me a list of all the times a letter appears on the left-hand side and a type appears on the right-hand side. And of course, this errors if I get anything that's incompatible. So I will want to do if I go back to this thing, something I will need to check is I might copy some of the old code just to make sure I'm not forgetting a important check. Let's go back to core. Analyze struct fields. That was the old function. Okay. Okay, so basically we check for each of the fields that the field is known. So if you try to create a structure and you give a name that doesn't exist, that's an error. Then we create a hash map from this list and we check first that we, for each expected name, we have exactly one value. Then we do this build type parameter thing. Okay. I'm tempted to copy this, even though the code will just be completely different now. Okay. So now why do I need this reference map? Yeah, okay. So this is something that I might want to persist as well. I don't have at the moment, like I only have a list, a non-empty list. So if I want to do a lookup of like, is this field known? I need to create a set. That's fine. I can do that for now. So this is gonna be this is going to be the set of all the fields. So struct fields is going to be a hash set from list of the first element of the struct raw fields, which is like a non-empty list of identifier and type. I make that into a list and I get the first element, which I guess I could do. That's the same thing. List fusion will take care of that, and I create a set from it that allows me to do check of like, is this field valid in a much faster way than doing linear lookups. Then I put a comment, check that all fields are known. So this is gonna be for each of the fields where I get an identifier and a field value, unless this identifier is part of the struct field, then report error struct unknown field. Type name is no longer something that I would want to keep. This will be... I don't have the name. I don't have the name of the struct. That's the whole problem. I guess the base name will be enough, and the base name is... I'm gonna actually just like... base name is gonna be name underscore base of the struct name, I think. Okay. So the error will be, for this base name, this field makes no sense. Okay. This can go away. We create a value map then. Okay. So fields map is gonna be this thing. Why do I put pure there? Why do I put some of the values in a pure? This might not be required. Because here that means... Oh no, because I want to make it a list and I do a from list with to do concatenation. That's why. Here I can use my new fmap2 thing. So that's a fields map. So now I can collect, I can do this check and collect... How did I call this function? I called this function parameter map. So I have my field map, and now this is going to be for each of the struct fields, which are the reference ones and the names, which is just a field name. But perhaps here I want to iterate instead. To create the type map, I will need... So yeah, here I'm going to iterate on the struct raw fields. And I will get the field name and the parameterized type. For each of them, I will do a lookup of the field name inside this field map If I find an empty list, that means there was no value given for the field. That field is missing. Oh, and I probably want to try to do all the fields in parallel to collect all of the errors, which means I'll probably want to do a traverse of this thing and try and compose. So this would probably be an ensure of get compose of traverse validate field dot try dot compose. And I move all of this into a separate function. Okay. This separate function, again called validate field, takes as an argument the field name and the parameterized type. And does, and it requires having access to the struct fields, to the fields map. So this is validate field with the fields map as an argument. And for each field, what we do is this thing. We do a lookup of the field name in this fields map. If it's empty, we report an error, which is the error struct missing field. And this short circuits, there's no need to have a pure afterwards. If we have, because HLint is gonna complain if I do that. If I have only one argument, only one result, that's the correct thing. So here I will need to build the type parameter map, which takes the parameterized type and then the type. And this expression is gonna be a typed expression because it is the result of doing this validation. So this will be a validated const expression. So here the type I am using is indeed gonna be the type info of the expression. Otherwise, this is the same. That gives me the field mapping. What I'm doing here is checking that all of the names I find are names I expect. Do I need that? It doesn't hurt, I suppose. Actually, I'm gonna need to do something else. I'm gonna need to create this param mapping thing. I don't have that. With the partial type, I have something very similar, but I don't have that. The question is, do I actually need that? Or is that just a remnant of the old approach that is no longer required? No, I think I will need it. I think I will need to do that and substitute. Because I will need to know, okay, for all of those type parameters I have found, what they map to, which will be a partial type, and that's fine. Yeah, okay, I still need that. And this might also be something that I might consider persisting in this, in the struct type info. I think what I'm going to do instead, so I'm just going to put the struct info in there. And have the entire struct info persisted, because that way I have access to everything I need, which is one of those things. Okay, where is you? There we go. Because that way I have the list of the parameters which I need. So now go back to validate type. Here, struct is just the info, which is this. I'm going to do the same thing for this function. Struct info. Okay. And I'm going to need one more place in build type parameter map. Do I need to do anything? I don't think so. And for refi type, however, here struct info is just the struct info. Oh, typo here. Info, there we go. Okay, that should be fine. So now we have the struct info everywhere. We can go back to... It's higher than this. It's somewhere around here. There we go. So now I no longer have something like the raw fields. That's no longer something that exists. This, however, is the struct raw fields of the struct info. And I could actually just do struct info, decompose it as being the struct info. And so I can go back to... I hope I don't have any overlap. Params values versus the other, which is name field info. Perfect. And that's the struct values. Okay. And I suppose then again that I will need I'm tempted to just there we go. I will need the base mapping, which is... So I have the partial type. Aha. Oh, this is annoying. There's another thing I need to persist. There's another thing I need to persist. Because I have the partial type. But the partial type doesn't give me the name, the type parameters. What I have is the partial names. No, it's fine. It's fine. It's fine. It is fine. That is fine. I don't need the partial type. It's okay. No, it's not. It's not fine. It's not fine. I will need to persist. Because the names is not the same thing as the type, and I cannot necessarily get the type back from the name. I need to persist one more thing. Here the name is important, but that's not the only thing I need. It would be good to have the type of the arguments, because the name contains the name of the arguments, but I will want to have the types of the arguments as well. Do I... Maybe that's a solution to all of this. Maybe I give up on all of those complicated names and thing, and than rather than persisting the name in the type, I persist the base name and the type of the arguments. And if I need the name, I can always reconstruct it at a later point when I have a concrete type and when I actually need it. Maybe that makes a lot more sense. Maybe that makes a lot more sense. And that makes everything simpler. Yeah, okay. I think that's the solution. That's the thing I was looking for earlier, and that simplifies everything. Because get type name basically disappears. Name stops having the same structure with the f parameter. Yeah, I think that is the right approach. So this is the struct base name, not its name, and that's just a base name. Struct, I will need to know type params, which are gonna be, however, those are gonna be a list of type tree f, and could even be a hash map from identifier to, but I think the order is important, so those are gonna stay. And with those, for type, when it is a concrete type, we can trivially recreate the name, which is what we will need. But for partial things, then we don't need that. The fields will be those things, and here's the cached struct info that we carry around to avoid having to do further lookups after we have obtained the type info in a given context. Okay, I think that's the trick. Get type name doesn't need any of this. It will be something that takes a type and returns maybe a name. Hpure, the need for Hpure just goes away. Okay. Means name, I can remove all of this. This is back to being called name. This is back to being called name. This is back to being called name. None of this is required anymore. A solution that's simpler. I like those. I don't need an ice for this. Okay. And so, for the last time, hopefully, we go back on all of those functions. So I think expect name can just go away as well, which is lovely. We love to remove functions, especially ones that contain internal compiler errors. That is lovely. And so let's do it in order. When I validate a concrete type, when I validate a struct, I don't have to create the name at this point. That is the base name here. That's the struct base name. Then we have the struct type parameters. Oops. Which is simply this params thing that we have here. We have the fields, which we have verified, and we have the struct info that we are passing around. For a partial type, this is going to be the same. We have the base name. We have the type parameters, which are just the params we have here. Which we have obtained with fuck, those need to be maybe things. So that means I will need to add the possibility of a maybe at the root, and I will just need to handle that. Okay. So this go is no longer required. Placeholder at root will be something else. This is back to being that. This is de-indented. Okay. Wait. Nope, we're good. The type parameters are type 3 regardless of what this is. Okay, so nope, this can be back to this, and I can undo this and keep the proper version. That's lovely. We love that. Okay, so here the parameters will be the result of going with Go. There will be things that can be maybe themselves. That is exactly what we want. This is now, I think, correct. Okay, and in refi type, we have here the struct info that happens to be the same. Struct name is just refi name is no longer something that needs to exist, is no longer something that makes sense. The struct name is just the struct name. The struct type params are gonna be changed. They are at the moment whatever those things are as input we need to do. That's just a refi type mapping on the struct type params. And the struct info is left unchanged. Okay. And now, with all of this done, the base name is no longer something I need to have in scope because it is just struct base name. The param types will be a hash map that will associate to the name of the fields, which is struct params, their type, which is struct type params. Now we are back to doing this. I'm gonna just back to doing this validate field. Validate field, we do a lookup into the fields map. If we found 0, that's a missing field. There should be a value for the field. If we find 1, we create the type parameter map. And for each of the types in the type parameter map, Ah, I'm doing this thing here. Okay. Yeah, I guess that makes sense. What I'm doing here is basically like I've said, like I've with my partial type on in the struct. Let me write it actually down. I have something that looks like this in my code. I am creating a pair and I'm not specifying the shape of the first argument, and I'm saying that the second argument is an array of something. That's valid. And the first thing happens to be 0, so this will be inferred as int. But here I'm saying the second is 1. 1 will be mapped to like, okay, then uh, I I already know it matches the shape, I think. I already know it matches the shape. Because basically I'm gonna here try to extract, oh, this type T here. Oh no, that's okay, there we go. So here the type of the second thing, I will create a map that says, well, the type of the second parameter seems to be int. And here what I'm trying to do is, does this match this shape, basically? Which is this type matches thing. Do I want to do it here, however? Do I want to do it here is the thing. I might not do it here. So I think I'm not going to do that at this point. Which means the only thing I need to return here is this list of type parameter map. Except I suppose I will need to change it to be a list so that I can collect all of the so that I can collect all of the different values for a given type, so I can check that they are consistent. Okay, so this goes away for now. Do I have? I don't have an ORed instance on my types for a lot of reasons. That's gonna make. It means I can't really do. How will I compare a bunch of different types for equality? I have a list of types, which I hope to all be the same. Excuse me. How do I should be able to make them comparable for equality pretty easily if I make one simplification, I think. I think the trick will be, so this is perfectly fine to do show equal and ORed, I think, and maybe even generic. So I can make an instance hashable type node of f. Of course, that it requires f to have this might not work. This might not work because it might require. We'll see. What I want to do here is this needs a show instance always. But I think I will say that the EQ instance, and here I'm going to try to do deriving show ec generic and make it hashable the same way. Which will require function archetype that I'm going to move here. to be also show ec word generic, because it has also a hashable instance somewhere, I suppose. Oh, it should have one. Oh, it's wrong actually. It needs to be nowadays. It no longer F and N, it's just F. N has been removed this evening. Okay, I don't think this is gonna work because there's gonna be a problem with like making instances because of this, I think. But we'll solve this when we get this. The worst case is we have to write them manually, and that's not the end of the world. And here, however, we are gonna cheat a tiny bit. And the EQ instance for struct type info of F will not use the things that we have cached because those come directly from they can be deduced from this basically. So the only thing that we need is to be equal. This function is defined as being equal on a subset of the things, and given some struct type info, what we compare for equality is the base name and the type parameters. If I wanted to do structural typing, here I would probably do something like, actually, the fields are the only thing that matter. If they have the same name and the same types, they are considered the same. But I want to do nominal typing, where no, it's the name that matters. So that's only required, and we can do the same thing for an ORD instance, where instead of equal, this happens to be compare, but we basically do the same thing. Okay. Okay. Having this, row polyformism, what do you mean? Remind me what you mean in this context. Actually, here I might not want to do... No, I don't think so, no. Here I'm not going to be able to make a generic... No, I don't think Haskell has that at all. Here I can't make a generic hashable instance. If I want this to be hashable, I'm gonna need to write it myself. And the instance for hashable is hash with salt, which takes some salt s and then the struct type info that I'm gonna decompose. And this is gonna be s hash with salt of the first field that I want, which is the struct base name, which I know is hashable. Hash with salt of the struct type params. Put that on a new line. Up. What do you mean to complete the words? You mean like this one? Like something like this? Oh, I'm out. That's just meta slash, which is a basic Emacs thing that doesn't do any like type aware anything. This is not like a how is it called again? The language server thing. This is purely like what are yeah, I think it's exactly what it is. If I describe key, it's not visible to you, but it is indeed dearbrev. Yeah, that's the one. It is dearbrev expand. If I put it here, that is the one I'm using. It's very basic, but you know, 90% of the time it's enough. Okay, so now this will never compile on the first try, but that means with this shenanigans here, we should be able to put those types into hash maps and hash sets and all that good stuff. So in here, I will be able to I build the type parameter map, which gives me a list of for each type parameter the types that I have found for it. And I'm gonna make that, so that's gonna be the raw mappings, I suppose, or just the mappings. And I'm gonna return, I have something wrong somewhere in my syntax. Probably, we'll figure it out. Here I will do a map from list, and with how do I combine two values for the same key? This is gonna be S union. I'm gonna do a set union. And the list I'm gonna use, which is gonna be an association list of type parameter to the type I have found, I will just do an fmap2 to transform the value. So within the list, within the tuple key value, transform the value. And I'm gonna do a set singleton, so create a set of one element, and I'm gonna then create that as a mapping from my arguments to the set, the union of the sets of the types. And I will need hash set qualified as S. I already have it. Perfect. Okay. And this case here, that I'm going to rewrite this way now that this is a lot more succinct, is, well, I didn't find 0 or 1 value. I found more than 1 value for this field. Well, duplicated field. Type name doesn't exist. I will need to have the base name as an argument to this function. So validate field here takes the base name, which is struct base name. Okay, so now I have this parameters map, parameter maps, which is a list of hash map of identifier 2 set of types. To create the one parameter map, I will need to do a union of the hash maps while doing a union of the sets within. I know that hash map has a unions function, but it does the basic union where the values are not merged in any way. So I will need to do a fold of a union with, basically. Unless my prelude has... No, I have a union with M, but I don't have a unions with, which I'm kind of tempted to write, actually. Unions with... Oh, why is it formatted this way? Did they run the wrong formatter on this? That is very weird. That's not... It's not the proper format for this. Like, that's the... That's Ormulu's, or maybe Formulu's formatting, not the one I use for my projects. Did I run it once and then forget that I didn't? I don't know. Weird. I much prefer this prefix version. Okay. So union with, as it is defined in here, unions is for a list. I could make it for any foldable, to be honest, to improve on it. So given some key that happens to be equal and hashable, and given some foldable t, this is going to take a t still, of hash maps, and will return a new hash map key value. But this also take first as another argument, how do we merge values together? If I look at union with, this is just a function from v and v to v. So v, we are halfway through to one of the best games ever. And unions with some combine values function and some hash maps that I probably don't need, is just, since those are hash map strict, I can do a fold L prime. And I'm going to do a fold L prime where the function I'm using at every step of the fold is, do I have it imported as M? Perfect, I have it in scope. It is M union with this function combine values. My starting element is the empty hash map. There we go. So that's unions with, and I can go back here, and this is unions with. I'm doing the union of a bunch of hash maps. And the thing, how do I combine values that have like a similar key? This is a set union. And now I have, for each type parameter, I have a list. Well, there's more work to do, I think. There's still more work to do. Because now is the point where, okay, here is my map of, for the type parameter t, here's all the types I have collected in a set. Here are the parameter u, here's all the types I have collected in a set. Now what I need to check is that this parameter map does not contain types I don't expect, first, and second, that it does contain a value for every type. Third, that there is only one value for each type. And I think there's a fourth, that it matches the structure that was given in the template. Okay. That means basically we're going to do something somewhat similar to what validate field does. Check unicity of type parameters. And this will be, the result of this will be the proper mapping from type parameter to type, which is the thing that we need at the end. So this will be the final mapping will be the result of doing an ensure. Yeah, because we can't continue after this, I think. So it's better to do it this way. Of get compose of traverse. I could probably replace it with a sequence because there's no nesting. I say that and I type the wrong thing. A try of validate param. Wait. I never specified what I'm traversing here. I am traversing the field name and the parameterized type that is part of the struct info. This is the struct values. That is the thing I am traversing over. Okay. So this is going to be something similar. I'm just going to do validate param, and I will see what values and what things I need to add. I will need to at least give the parameters map for sure. And I will be iterating on the struct type params. Okay. So now let's add, and I will probably need the base name as well here just because I will need it for errors. Validate param will take type map, the base name, and for each param, we'll just take the param name and the partial type. Okay. What do we do here? Oh, that's the problem. That's a function. There we go. What do we do here? There's one thing I just thought about that I need to fix before I move forward with this. What was it again? Yes, I want to go see the old code. Core. To copy this part of the code. So that I have the errors I was using in the original code. Okay, for reference, this is what we have. So, for each field, what I will want to do is look at the types that we found for that particular field, which is going to be a lookup in my of the parameter name in my type map that we have created. If we find nothing, that means that we don't have enough information. We didn't have a way to know that type, therefore it must be provided. This is report error struct ambiguous type. That's the base name. So the type parameter could not be deduced. For instance, you have a struct S that takes a parameter T, but none of the fields depend on T, it's just a phantom value. Then the type must be provided because it can't be deduced from the fields. So that's what this error means. Now we have found the types that are associated with that type parameter. Now we can look at, let's look at hash sets. We can look at the cardinality of the set. And is that just size? Is there a pattern actually? Can I try to do pattern matching on the constructor of the set to just see if I can get one value of it or something? because I will need to know the one value in it, basically. I don't seem to be able to do that. So I think I'm going to do the same thing I was doing here. I'm going to do a case hold of S2 list of this instead of doing an on nothing here. And empty list means either I got an empty set, which is impossible, or the set was not found. That this error. One element, one concrete type means we have found the one type. Here we still need to do a check. We still need to do a check. And what I want to do is see if I can change this build type parameter map thing. No, I can't really do that. So I'm gonna have to do another function. I'm gonna do check type pattern that takes a partial type and a type and returns basically nothing, just checks that it is consistent. And that is just... Oh, why did I write it this way? I can make it point unless I need expected. Oh, I need them for this. Okay, okay. Because otherwise I could have made this thing point free because this is just going the function with the same arguments. But no, I need them for this. That makes sense. So the same thing is true here. Okay. And so here, this is not a matter of left or right. This is a matter of nothing on the left-hand side. That's perfectly valid. Pass, we do nothing. And for all of those, this is not right, but just. And for all of those, we do nothing. And there we go. This is purely a, I guess I can create validate to be consistent with the rest of this function, validate type pattern. Same logic of we just check that the template that was given to us maps what we got. Okay, validate type pattern, pattern, which means if we go back to this, when we find a concrete type, we have the partial type here. The only thing we do here is validate type pattern using the partial type and the actual concrete type that we found. And we can return here a tuple of the parameter name and the concrete type. Last but not least, if we find more than one thing, then the type was ambiguous. So that was the error wrong type that's done. Struct ambiguous type is done. And this will be the error struct incompatible types. There is an issue here. There is an issue here. There is an issue here. I'm using equality for the set, but that is not correct. That is not correct. Okay. The problem with it is that I am making the assumption that two types are the same if and only if they pass this equality test. That is not true because of void. Because of void. The problem is this. If I say x equals panic, the type of x is void. But void type checks with everything. That means for all of those functions, I need to handle the case of void separately. So I'm going to need to change a few things. So whenever I find, yeah, here, whenever I find a void type, it doesn't matter what is on the other side. Wait, no, that's not true. This is more whenever I find anything here but a void type on the right. So like, oh, I'm expecting some kind of type, but I found void. That's valid. It's perfectly valid. The only thing is I might need to go recursively. If it's a struct, like I might need to do all the recursion, basically. Because the problem is, yeah, if I don't go recursively, for instance, I'm expecting a struct on the left-hand side and I have void on the right-hand side, I still need to go recursively so that the type mappings are done properly. So that means, and I think this was something I didn't have pre-refactor. So I'm finding bugs in the old version by doing this. You know, progress. Enums will be fine no matter what. So here, the only recursive case that I need to care about. Oh, I don't handle function type in this. I don't. Okay, you know, I handle it by catching it here. So if I have a struct type and I have void in the actual type, that is still valid. I don't do any check here. I just go recursively. And this becomes void type of the struct fields, basically. I'm saying, oh yeah, sure, that struct was here, and all the fields were void. Okay, so this handles, well, I need to put this one then. So that's the case of I have handled a struct on the left, void on the right. I can then do anything on the left, void on the right, because this will always succeed. I can remove this indentation, I think, at this point. Actually, I think I'm just going to do this now that it's getting more complex, just for readability. So, identifier perfect. We return the association, whatever it is, even if it's void. Void struct on the left, void on the right. We go recursively by claiming that everything is void. Anything on the left and void, that's perfectly fine. We just don't return anything. Two types that happen to match. We don't have any mapping to return. That's all good and gravy. Perfect. Likewise for those. Enums and structs remain the same. Okay. Now, for validate type pattern, I have to do the same thing, where here I don't need to go recursively because I'm not trying to build anything. So if I have void type on the right and anything on the left, it always passes. It's all good. Because again, void is compatible with everything. That also means that I can go back to validated and I can remove all of those equal and order and everything because they are probably not going to be... I don't want to use them because they ignore the problem of void, basically. They ignore this problem, like having equality on types means ignoring the case where types are compatible if different. And void is the big one. And if one day I do structural typing instead, then yeah, the equality thing just goes away. So I can remove anything other than show for all of that stuff. Okay. This function is probably wrong now. Yeah, now it's wrong because now I have that becomes just a name made of the struct base name and of I can't. This is name struct base name f mapped into map maybe of get type name of the struct type params. There we go. That is fixed. So now we've handled void in those functions, which means we can go back just I'm looking at the fact that I do cache the struct type in struct expressions in some of them. Will I need to cache more than just a struct type? Probably not. I think it's fine. Okay. Another thing that bothers me is that I'm writing this case for the struct const expression specifically. This logic will be true for struct expressions, for function calls in constant and functions. I will want to not write this 4 times. I'll have to figure something out. So here I am no longer creating sets. So instead I will be I will be creating a list and I will be combining types with concatenation. Which means here the unions with no longer becomes the set union, it just becomes concatenation. Which means here the set to list is no longer required. I always have a list. And now I can't do just this, there's only one type or there's more. there's always multiple possible types. Hello. So we always find multiple possible types because we no longer have a set, we no longer do the deduplication. So here we need to check that's like unless they all match, basically, whatever that means, we need to report that it has incompatible types. Then we validate the type pattern after choosing the concrete type in some way. And then we are done. So let's go back to look at the old code. I was using something called most specific type and something called types all match. Types all match. Oh, so this is basically, I'm writing some very basic type inference, which is going to be used in technically four places, three places in the code: function calls in functions, struct expressions in constants, and struct expressions in functions. And the syntax of which looks something a bit like this. Where's that thing? There we go. If I have a struct pair that has two arguments like this, I want to be able to say, well, this constant here is constructed as being a pair with x0, y1. But as far as this expression is concerned, I did not specify the arguments of pair, so they must be deduced. And there's a lot of complexity there because I will also allow placeholders there. Like maybe this type is like, this is not a known type in this context. So I can do something like this, or I could allow something like, foo of underscore here, just like this is the shape of what I'm expecting, but I don't want to specify what this type actually is. And therefore type inference must be done by comparing the values of the fields to then look at whether they match with the types here. But the fields don't have to be this. This could be like foo of u or something. So here I would expect, if this is the case, then this would need to be a foo of something. Like, it can get quite complex. So this is what I'm doing at the moment. I am almost done. The reason why it has taken 4 hours to go through it this evening is, first, that it's complex to do, and two, it's made me, I had to rethink a lot of what it means to validate a struct type now that I have split this analysis phase into two. This refactor makes me change a lot of structure of the compiler, and I end up having to rewrite a bunch of things. So between the changes in the structure and having to rewrite all this complicated logic, I've been at this for quite a while, but we're getting quite close to the end. I have two functions I need to port from the old code. Types all match. There we go. Which is basically the Cartesian product of all the types in a list and check that all of them match this type matches condition. Let's do that. Let's copy this and put it in my helpers here that's going to move into another function at some point. So this is a list of type. Yep, that's perfect. And the only other function I required was something called the most specific type. I mean, proper type inference like another thing is horribly complicated and out of scope for this, but it is a fun project. Like, again, when I have a version of this compiler that works, we have a first version of a language, we've done all the initial goals, then maybe like next year we can start thinking of like, how do we extend the language and maybe try to like simulate a heap or something. Like there's a bunch of things we could do, and better type inference could absolutely be an interesting thing to do. Although since it's based on Rust, I don't know like how much I can, like I don't think I can go further than what Rust does, but you know what I mean. There's probably more interesting things we can do. Most specific type, what is this? Oh, of course. This was from a time where, since I was doing the name resolving and the type checking validation at the same time, I had to run the analysis on generic functions in which I didn't know all the concrete types yet. Having done the split, now I do name resolution first, completely regardless of types. It's perfectly fine. And then I only do type checking on concrete functions, on instantiated functions, on functions whose type I know. So a lot of this goes away. So most specific type was like, okay, I found a bunch of different types that are all compatible, but let's take the one that has the most information in it. Now, since they're all concrete, they are supposed to all match. The only thing I need is to find basically if any of them is void. If any of them is void, that's the one I need to pick. Because that's the only exception to the type matching. Now, type matching is basically equality, except for void. So I'm not going to copy most specific type. Instead, because type matches is basically if either is void, it's true. Otherwise, they have to be really the same. Oh, I think this is now incorrect, actually. No, this might be correct. No, it's not. I need those two things to be the same. And struct match of S1 and S2 is struct base name S1 equals struct base name S2. They are the same original declaration, and of zip with type matches between the struct type params of S1 and the struct type params of S2. They refer to the same base struct and their type arguments all match. There again, void will be accepted. In fact, do I want, for type checking to be more interesting, come to think of it, for type checking to be more interesting, in here, I probably want to select the non-void type, if any. Because if I select the void type, like, oh, one of them was void, this whole thing is false anyway, then what I'm forwarding up is void, which means any further type check up ahead will be considered fine because they're the type that we inferred was void. If there is another type, like I have found, like this is pair T, and one of the field is int, the other is void, I know that T has to be int because one of them is, like I found int and void as possible types. If I keep int, then any further thing down the line that is not compatible with int will fail to type check, which I think is better. So here this is types all match of the possible types. Unless that's true, report that those are incompatible. and concrete type will be um, how do I want to do this? How do I want to do this? I basically want to iterate over that list, and if any of them is not void, return that list. And if it is, if I don't find anything, then void it is, basically. So this is going to be find first non-void of the possible types, where find first non-void is going to be a manual recursion so I can short circuit. Unless I do... find... does find... find gives me... okay. But I will need to do a... I don't have equality by definition, again. So I will need to do some kind of case... this is find with case void type is false, anything else is true. So any other type will give me something. And after that, I do a from maybe void type. Okay. So that should be everything. For each field, I have checked that there's only... for each expected field, I check that there's one and only one field given. If there's none, that field is missing. If there's more than one, it's duplicated. For all of the fields, I then extract the type parameter map to do a mapping from the type parameters of the struct to the types I have found for them. Then, for each expected type, I do a lookup of all those types I found. If I find nothing, then it is ambiguous. It cannot be deduced from what I have from the fields I have given. If I find types that are not compatible with one another, the types are incompatible. Otherwise, I find the first non-void, and I return this mapping. There's one thing I haven't done here, but since it's theoretically an impossible case, I think it's fine to not do it, which is, what if I find a mapping that contains a type parameter that doesn't exist? Like I find a mapping from t to int, but there's no type parameter t. That's not supposed to happen. That would be an internal compiler error. I could add it as a sanity check, but since it's something that should never happen, I think I'm fine not including it. Okay. With all of that done, we've checked the unicity of type parameters and build parameter map. We have the final mapping. Now, what can we do? We can reify the type So what we're gonna need to write here, we're gonna need to write a struct type which contains the thing I need there. And the struct expression will be not the... it is the validated struct type, actually. That's fine. I mean, it's not actually a struct type, I suppose. It might not be a struct type maybe maybe the struct info is enough. Maybe just having the struct info, which is the name of the parameters and the values. No, I think having the full type is what we need. Not what we need, just it avoids having to do... It avoids having to do some checks later on. Yeah, I think it's better that way. Okay. So indeed, this will be a struct expression, a const expression in this case, that contains the validated struct type, the validated fields, and is typed with this struct type, because that's what the type annotations are for. Okay, so at this point, the only thing we need to do is to create this validated struct type, which is no longer struct... It's called a struct type info, actually, but that's the same thing otherwise. Well, actually, I need to change that here. That's info here now, and that's... Where are you? Here. Why did you hate Haskell? What was... I suspect the problem was more with the course and less with Haskell. Because if you have no familiarity with functional programming and it's not taught well, which sadly in the case of Haskell is fairly common, yeah, it can be rough. That's true. Because Haskell is fantastic, but it is hard to teach in my experience. Well, it's hard to teach well, I suppose. Because to teach it poorly is not that complicated. So here we will just need to create the struct info at the end, which will contain all of that. Let's copy and paste that. And put a bunch of equal signs instead. The struct info we already have in scope. It happens to also be called struct info. That's convenient. The struct fields, the base name hasn't changed, so that's convenient. The type parameters will be the proper type. So that's going to be... Last time I've done this, I've lost half an hour. So one day you will have it and I will do the monad runs again. I mean, if you want to see a older version of the monad rant, my YouTube channel has one of my two only videos on my YouTube channel is the monad one. That is basically a slightly clean version of the monad rant. But I have it as an incentive on the thing because like some people like to hear me rant about them. Okay. I wanted to just do something quickly. I wanted to look at what the type parameter is. It's going to be the list of the types of the type parameters, which the final mapping that I obtain with validate param will be an association list. So it's going to be, this is going to be the struct type params, which are going to go here, struct type params. As for the fields, this is where we are going to need to do some replacing. So we have now, we can create the mapping. The mapping is the type mapping, the final mapping is a hash map from list of those struct type parameters, which I suppose here then as a result, it needs to be second of this. And now for each field, because here struct fields I have in scope will be the parameterized one, I need to do a reify type. I have the mapping, I have the parameterized type, and I want to get a type out of it. So this is, oh, and this is supposed to be a total function. It's not supposed to have errors. Any error would be a panic, an internal compiler error, not an actual user error. It would be a bug in our compiler, not a bug in the user's code. So what we do is, this is an fmap2 of reify type using the final mapping of the original parameterized struct fields. There we go. Took 4 hours and a half. This function is done. A lot of it will be deduplicated at some point because I don't want to redo this when I do struct expressions in functions. Whew, okay. Now, what do I tackle on next? Because I think at this point, we have ported all the code pre-refactor for checking the validity of a const expression. Wait, why do I have go? Or I guess it's just to avoid having... Do I use it anywhere else? I don't. Maybe I shouldn't do that then. Since it's not intended for recursion, I should probably do this. This is a case located of. So that's all the possible expressions we find in a constant. And we have forked to a different function for every single one of them. What do we do when we find a path expression? We validate a const path expression. When we find a cast, we do that. We validate the expression, we validate the type. This is a concrete type now. And then we validate the const cast expression with both of those. When we find a field access, we validate the const expression, and then we validate the field access expression. Let me actually check that this is still okay now that we do. I'm just gonna... No, it needs to be typed probably. Let me just quickly check that the field access expression is not broken by what we have done so far. Okay, since it's a constant, I don't do any type on check on the type. I'm just saying I must have a struct value on the left-hand side. No need to do any check. This must be... Why does it have 3 arguments listed here? Struct const expressions seem to only have 2. There we go. Oh, this is very wrong. Oh, wait, no, it's not. That's just unimplemented here. Okay. Okay, so that's fine. So we are done with functions. No, with constants. I think I'm gonna start breaking this file into sub-files just because it is getting a bit unreadable. So within validation, I'm gonna create an expression module. And I'm gonna move... the problem is if I do that, I'm gonna have some cyclic dependencies because all of that stuff needs to be able to call validate recursively. That's fine. I can always create a boot file just for validate. I think that's fine. I think that's fine. Okay. So let's do every exp function. Okay. And that's all of them. And you all go here. Perfect. I'm gonna copy all of that. Here, I'm gonna add. Oh, that's very wrong. Analysis core no longer exists. Diagnostic no longer exists. Instantiation no longer exists. All of this is gone. Now I have validation monad here. So I replace that here, and I have now also exp. I'm going to remove this comment for now because I don't know yet how this is going to be organized. Validate const, validate struct. Those are the top level functions. Validate function type will stay here as the top level thing, I think. Validate function, however, will have to move. Unless it stays here. This might be something I keep as part of the API. No, I think it's going to stay here. That's going to be a top level kind of thing. Retrieve type is something that's kind of broken at this point, I think. I'm not going to do that. Retrieve things are things that look up in the scope that we expect to either have found in dependencies or that we will need to recursively validate, which is where we have the cycle detection and everything. So this is what in the old version of the code was called context, and I'm gonna keep it that way. Okay. So that's the stuff that does look up in the context and will handle errors properly. Do I want to separate all of the type handling into something else? Probably, because I have all of this concrete type, partial type, built-in type, and so on, which is going to be very complicated. I want to avoid having a util thing. However, a lot of those functions are just used across a bunch of things. Expect const int. Yeah, a lot of those are just like, okay, I have a value that has been validated. I need to know that has been resolved. I need to now check that it is exactly the shape that I want. Which I think would be assertions. So I think those expect things that report an error or even an internal compiler error will go into a separate module, which I am going to call expect. That's straightforward. I'm going to copy this, which is the fixed version. Okay. I think all of those will go into type. This comment can go away. So that's validate concrete type, validate partial type, validate built-in type, build type parameter map, validate type pattern, reify type, type matches, types all match, perfect. That's all type logic. That all goes into a type module. Okay. I think the only thing is that we'll need to make sure that those functions don't have like cyclic dependencies. The only one that will have is context will depend back on validate. That's fine with a boot file. That's one function. I'm okay with that. However, the others, I've tried to stick to the thing I was doing before pre-refactor of every kind of function has its own prefix, validate for the things that are like kind of the entry points of all of this. And retrieve, get, whatever, like expect. I try to have them have like prefixes that indicate what they're supposed to be, and then avoid any kind of secular dependencies. And now in validation, my root module, I only have the top level validate, given a definition, validate it. And the top level thing, const struct function type and function. Okay. There's still so much more to do. We are nowhere near done. I've been at this for a bit long. I'll get a drink. I'll be back in less than 5 minutes. Yes, indeed, less than 5 minutes. I just, since that the camera shows basically the entire room, I don't like leaving the camera on if I'm just, even if I'm just going back there. Okay, so amongst the things that are missing, when we do the validation of types here, we've spent a lot of time on this. There is some duplication there, which is a bit annoying, but that's fine. One big thing we're missing is how do we handle type aliases? Is there any kind of work that is done as part of the name resolving phase to try to be like, oh, that's a type alias, we do the forwarding? I don't think so. If I go back to this, I believe that if I do a resolve type alias, yeah, I will emit a type alias info. So I haven't done any of the top level scope, I think. This takes the scope as an argument. I haven't even defined what a scope is. Have I? No, it takes a scope as an argument, but I haven't even defined it. Oh, I do have it in the analysis still, apparently. Because in the old stuff, of course, I do have it. But in the not old stuff, Oh, it is there in interface, which, yeah, I suppose is correct. It's path to an empty role. Yeah, no, okay, that makes sense. That makes sense. It is defined. And in here, do I have... How do I scope things? I suppose that just for a block... Yeah, I get the scope, I update the scope, and I restore the scope afterwards. Yeah, okay. So that's fine. Okay, so since that is not done, when we take care of types, we are going to have to take care of type aliases and do the proper substitution. That's going to be the case here as well. We will try to see if we can deduplicate code across those functions. The difference between concrete type and partial type is partial type can have information missing, like a placeholder, which is used for a type inference. Now, that's one thing we have to do. But something else we have to do is start doing some of the other validation. Do I have to do any validation of type aliases? And I think the answer is yes, because type aliases need to do this thing where they need to do this thing where I check for cyclic dependencies. Since I have no way of branching at the type level, I have no type families, nor do I have like kind of union of types. I have no way of branching. Therefore, if a type alias points to itself, or it points to another type alias that points to another type alias that points back to the first one, that's invalid. I already have with this definition stack kind of thing as part of this validate thing. I already have the cycle detection in place with here this report error cyclic definition. But that means there is stuff to do for type aliases. I cannot just rely on the old version of the previous phase. What do I need in the output is the thing. What I need to know is, okay, a thing is a type alias, and here are the type parameters. I will need to be able to do a translation from one to the other, basically. So what I will need is a parameterized type for the type name, I suppose. So I will need, let's go back to validated. So here I have struct info, function info, which are duplicates of those struct info, enum info, and so on, which I will try to deduplicate later on. For now, they are a duplicate, and that's how it is. So type alias info, what do I need in this output here? The identifier is no longer required, but I probably need to cache the number of the type of the name of the parameters, which will be important, and the value, as I've called it in a bunch of places, will be a parameterized type. So a type in which, in some places, I don't have a concrete type, but the name of a type parameter. So that's going to be the result of processing a type alias. And that means that I will need and that's going to be part of my interface at some point. That's wrong monad. This one. Here is... Yeah, this is completely wrong now. This is completely wrong. Let's put this and this side by side. So the result of a module will have to contain the name, the set of identifiers that is correct. The definition cache will be useful indeed. Oh, why do I have it like with location here? I suppose having the location is useful. It means I can include the thing defined at this location in my error message. So I probably want to make that a definition cache, I suppose. However, that is not a name, that is a base name. Very important distinction. Then, the symbol cache. Yeah, I don't think I need a lot of things that are beyond the definition. So I will need to have... So that's going to be basically... I guess I could change this to be interface. Nah. But basically, the state of my validation contains the stuff I know that is the... Okay. So here is the thing I've made that I disliked, and that now is the time to fix it. Here I have the types, the constant, the struct, and everything that I have found in my dependencies, and that I have found locally when resolving the file. This contains both the result of everything that has been processed before and what I have accumulated as part of the current file. I disliked that because it made what is input, what is output not as clear. I suppose the way to fix this is to instead having the duplicate version. There's a type that is in the reader that comes from the things that are accumulated from the dependencies, and there's the types that are local, which are the ones I have created locally. This is more verbose. It is also more clear. So I think I prefer the more verbose option. So what will I need? Will I need the symbols as part of the interface? It will definitely be in what a module exports, but I don't think I need it as part of what needs to be available for the validation. If I have a module A that depends on the module B, I don't think I need to know the symbols of module B to be able to compile module A. I'll need it to link at the end, but we're not there yet. So I think while the interface of what a module exports will require a symbol cache, which will not be a function info resolved, but a function info, which will probably be at some point a function info validated, although at the moment that is not a thing. But that will definitely be something that I need. I think this is going to be this output symbol cache, basically. So there's no longer a distinction between global state, local state. It's all the local state. I still don't know if types is required. I am not convinced it is. I might move it away for now. The definition cache definitely required goes here. The function cache, do I still need that? Not in this form, at least. Not in this form. Aha, I might need the symbol cache still in here because because of generic function instantiation. If I have a module A and I have two modules B and C that depend on A defines a generic function that foo that takes has a type parameter T. When I compile that A first, I don't generate a symbol for the function foo because it is generic. If both B and if I have like B that depends on A and C that depends on B, if B instantiates that function foo with an int, I need to generate a symbol for it so that it can be linked properly. And if then C instantiates that function for int, I probably want to include it in the symbols of C, but I would like to avoid recompiling it, reinstantiating it if it's not required. So I do need a symbol cache here to avoid having to recompile functions that I don't need. The function cache is no longer required. It is a relic of when the analysis was one phase and not two separate phases. So that goes away. However, I will probably want to have the new things I have added I will want to have the constants, which is going to be a constant cache, which I'm going to have to introduce. I will want to have the struct cache, which will be a struct cache. That's basically to avoid having the definition thing again. The downside of not having a unified cache like I have for definitions is that I have to do like, oh, what kind of thing am I looking for? I need to go into the right cache. The upside is, oh, I'm looking for a struct. I look into the struct cache. I then don't have to do a check that the thing I got matches the shape I expect. So that's the upside. Maybe I'll go back on this, but for now, I think this is fine. The queued instances are something that is completely local, isn't required to be anywhere else. And I think if I continue this logic, I will need, unless I decide that I don't want to do instead of doing a cache per thing, like a type alias cache and so on, do I do a cache of definition, basically, which would be a bit overkill? The downside is, again, if I do that, I will have a bunch of places like, oh, I know this thing is a struct. Let me do a lookup in the definitions, and then I have to do something that like, oh, this thing needs to be a struct, and it's an internal compiler error if it's not. The upside is I don't have to do a cache for all of those things. I have the validated definition cache, and that's it. I think I like it slightly more. I think I prefer the unified cache a tiny bit more. So that means that we change everything again, as is usually the case. So this is the resolved definition cache, which I still need to keep around because generic functions will not be available. I will need to be able to access their definitions. Do I only need the definitions? Do I only need the definitions for functions? Everything else, I will only need the actual resolved cache, validated cache. So that's probably going to be the case. So I can keep a function cache, which is going to be for a base name. I will need the location, but this is going to be a function info resolved. The symbols will be the function info validated. But using the actual full name. And the definition cache, the real one this time, will be a hash map from name to, without the location, the definition validated, which implies that I will use the same trees that grow approach, which is not the case at the moment, which we will need to do at some point. Okay, so what is the result of compiling one module? Well, compiling, before we do code generation and everything, but like getting the interface out of a module. What is the name? What is exported? The definitions, which is this, the symbols, and the functions. To be able to compile a module, I'll need to have the interface from all of its previous modules, which will be... If I don't include the module name here, I could almost just include an interface there. But I think I like this distinction of like, that's the interface of a module, and also I will be carrying around a aggregate version of all of this, which is different. So I think I will prefer to, because that's the module name I'm compiling at the moment, which is different. So I think I will prefer to do this. Of course, exported makes no sense in this context. This is definition, the symbols, and the functions. And I might even do, symbols last. Okay. Now, that means that here in my state, I will still need all of this. I will need, well, not all of this. Not all of this, because the definition cache that I run the validation with will include I will also need to have access to the previous definitions that are the ones of the module I'm currently compiling. So that's the aggregate stuff that comes from aggregated dependencies interfaces. And I will probably need local module info. I will need the local definitions, for which I am not going to use a cache type alias. I am just going to say that this is a hash map from base name to with location definition resolved. Okay. Okay. Without the typo, it's even better. Now, the local state, the things that are going to be modified over time, there is going to be the result of what I'm doing. So the result will be this basically, the definitions, function, symbol, there's going to be the interface. That's the result of what I'm building. So I will need, I don't think I need the exported stuff as part of this. So I will need those three, I think, which are the output. So there's going to be the symbols, the definitions, the functions, and the symbol. So let's copy that. I think the types are not going to be required. I'm going to keep it for now just in case I'm being wrong with this. Constant struct go away. They will be part of the definition cache. I remove this, it feels ugly. I'll document this properly, but not in this way. The queued instances are important. This is, since I have to resolve all the types first, I resolve all the function types first, and then I will go through the functions. The only thing is, this is going to be more complicated than how it used to be, because I will queue all of the instances, and then I will start instantiating the functions, which might create more functions to instantiate. So there might be some state shenanigans here. This might need to change, but something like that is going to be required. The context is important because since definitions might depend on one another, the way the cyclic dependency thing works is I am analyzing definition A, it depends on B, I push a new context on top of the current one, I analyze B, and then I go back to A where I was by popping the context. That's what it is. Validated is just which of the things have I validated already, which means I can probably... The definition cache is a base name, not a name. And as a result, since now I have a definition cache in my output, I don't need validated anymore. I can just look at whether... but no, okay. Because the way I was doing it before was, rather than having the actual definition cache here, I would have a map to maybe values, and the presence of a nothing in the map would mean we've tried to validate this thing. There's no need to do it again. It just failed, is the thing. Having the set instead means rather than doing this, we know rather than looking at a key in the map, we just look at the set. Yes, we have validated, and then the map actually contains only the actual values, regardless of. And I think I slightly prefer this validated thing. And the definition stack is what I'm using. It is somewhat similar. It is a set that matches the context, but that I use for faster lookups than doing a linear search through the stacked contexts. Okay, that looks a lot better. But that did break everything, so with this monad there, let's go through the files I have done today, and let's check what we have changed. So retrieve constant is something that simply cannot exist in the same state anymore. So this is going to be lookup remote constant, then lookup local constant, and then if that fails, attempt to validate. Now, lookup remote constant will be doing a lookup in the VI definitions. So this definition cache that comes from the dependencies, and I do a lookup of the base name. And I expect constant out of this. Because not finding it in the cache is perfectly fine, but if I find it in the cache, it must be a constant. There's a bit of a snag here. My expect things... No, okay, they're expect in the sense of like user error, not internal compiler error. Okay. And this is fine. The only thing is I will probably want to do that as a traverse, because this gives me a maybe value, and I only want to do the expect constant if I did find something. Okay. Then, if that fails, I try to do a lookup of a local constant. And that is basically the same thing, where I look up in the VS definition. This is not a uses, this is a views, because this is in a reader. I look at the local definitions, and I try to look for the base name, and then I traverse with expect constant. Although I guess, since all of this will just be getting me a definition, since all of this will be giving me a definition, I can probably do the expect constant here at the end, rather than doing it at every step. So definition will be the result of doing this thing, and here I will return expect constant from the definition, which will extract, and this is probably going to be a const info, and I can probably just export that, I suppose, because I don't need any more information than that. That's all it needs. So expect constant will return that, basically. Okay. Okay, so this goes away, this goes away. So if I did not find it in the constants that I have already taken care of in my dependencies, or locally in the ones I've already taken care of in this file, then I will attempt to validate. That means I retrieve the definition, which is this thing here, that I will do in a second, which gives me the previous definition, the resolved, not the actual, the validated one, the old one. Retrieve, and I might want to change the name of retrieve definition to be clear about that. Retrieve input definition. Okay, which must be found. It's an error if it's not found. And so I can give it to validate. And I think I will change validate to always give me the corresponding definition of a thing. So now this is just validate after doing a retrieve input definition. retrieve struct, which has a typo here, is going to be very similar. So we're going to do the same thing. We're going to attempt to do a lookup remote struct. Then we're going to try to do a lookup local struct. I think since now I don't do the check at this point, I can probably instead retrieve, and I can do a lookup remote foreign. What's the best word for this? What's the best word as opposed to local to indicate something that comes from a dependency? Remote or foreign or something else entirely? I think I like remote just fine. So lookup remote definition. Which is a definition validated. And lookup local definition. And I can copy this. Definitions. So this is the one that looks into the reader that comes here. That is the one that is the input to the whole thing. This is the one that looks into the location. Local definitions. That's the one that looks into the things that we are currently processing in the current module. And that's just a one-liner, but I like having a proper name for things. So let's go back to constant. This is lookup remote definition of the base name. Lookup local definition of the base name. And I guess this is also purely a thing that's not dependent on the type. So I can generalize this as well. I can generalize this as well, and maybe instead of this remote definition, local definition, I can probably do a lookup definition, which is going to be basically a retrieved. Well, do I want to do a retrieve? Yes, I think I want to call it retrieve because I want it to fail if it didn't find something, because it means an error happened somewhere. So I'm just gonna copy retrieve constant altogether, put it here. This is gonna be retrieve definition in the sense of like the validated one definition, and that gives me a definition validated. And it does exactly this thing: lookup remote definition, lookup local definition, attempt to validate, exactly like we were doing. And those are just exactly like they were. Okay. Lookup remote definition, lookup local definition, and then, if neither of those work, attempt to validate by calling validate on the retrieve input definition. There we go. So I have retrieve definition and retrieve input definition, which gives me a definition validated or a definition resolved. Next, I can change my retrieve constant, which is no longer any of this. Retrieve constant is simply retrieve definition into traverse expect constant. Retrieve struct is now the exact same thing, but you know, with struct instead. There we go. That's a lot better. I'm gonna need to include expect in this. And expect here is going to be one of those functions that check that we did indeed get what we want. So I have expect const that given some monad m. Oh, did I actually type them properly? Yeah, okay. Monad m is incomplete. We will have to do something better, but for now that's going to be good enough. Given some monad m and some definition validated will give me a validate m of, for a constant, this will just be a typed const expression. Oh, I need to make sure that the types are still correct. In context, typed output const expression, yep. Output struct info, is that correct? Yes, it is. Well, it might change in terms of how its name, but that's, yeah, that's something that has roughly the right shape. So here, expect const will be a very simple case of, is this definition a how's this definition done again? Is that a const def with some const info? Yes, perfect. Give me. I will probably have a special type for this. There's going to be const info, I think. It will just be the typed const expression when I do my trees that grow mapping appropriately. And anything else will be report error not a const, and which with whatever this definition is. Okay. Expect struct will be the same thing, except, you know, if it's a struct definition, aha, but do we need to do type aliases here? We probably need to do type aliases here. We probably need, if we get a type alias, to be like, oh, maybe that's still, well, I mean, for a const we don't, but for a struct we might have to do that. So here, if we have a type alias definition instead, with type alias info, I will have to do something that is currently unimplemented. Okay. Oh yeah, I have this thing, expect type, I can use in place. Oops. In exp. Do I have a bunch of type matches? No, I don't actually. I have removed them. That's good. Okay. Okay, so that makes sense so far. I think I will never expect a type alias. It's just going to be in the way of expecting something else. Okay. So I think I'm going to just put that back, put the monad back. So I have the definition of the state and the reader that I can look at to remind me what they are. I've been through context. I've been through expect. Let's go through types. What has changed here? Validating a concrete type will be, okay, I need to get the type information from some path info resolved. I think none of this has changed. What we'll need to do is handle type aliases and other things and type parameters, because those will need to be, yeah, they will be there. I suppose I can work on this. There's no reason not to do that now. So if I let me just quickly check. Validate built-in type should be straightforward. Yep. I guess I don't even need to check the type parameters. Void. Yeah, void is. Yeah, I can change that here. Okay. What about structs in the case of validating a type? I need to retrieve struct. So I got the struct info by looking into the context, either my remote definitions or my local definitions. Aha, I suppose that there is an issue there, which means that now cyclic dependencies in structs no longer works, even when it would be fine for them to exist, I think. No, it's fine. No, it's not. No, it's not. Okay. It's not. So I am trying to get the type of the fields of a struct, and it depends on another struct. So I do a validate of that other struct, and a depends back. Oh, sorry, I hadn't seen your question. I've been trying to find recently a way to save my buffers for this, but no, since I haven't found a good way to do this, and this laptop I currently mostly use just for the streams, I just keep my Emacs open between streams, basically, so I don't redo it manually. I only have to do it if I reboot my computer, which happens, every few months. But yeah, I was looking into trying to find a way to save the buffer shape so that I don't have to actually redo it manually every time. One thing is I use is a small module that was written by someone in the same computer science school than me 20 years ago, which gives me like the virtual workspaces with Emacs. So I usually have like main code on one, I have compilation window on two, and I have Git on three. But and that is like this idea of saving things across different workspaces. That's a module I use. But for this layout with like the feed, the prompt, and so on, I do that manually every time I reboot. I have it bound to Control C plus number or Control C plus arrow to switch. So I do my layout once per workspace, and then I just use the workspaces. And what it does is basically, and I could look into how it's implemented to actually do the persistence, but it basically keep like in memory of the Emacs session, the layout associates like a layout to a buffer number, and when we switch to like buffer two, it just restores the buffer shape of associated with the number two. It's not a package in either of those because it was written by someone in the same school as me 20 years ago. I know some packages do similar things, but I just use the one I've been using for 20 years because it's super useful to have that. I have it. If I just do that and I go into my Emacs vendors workspace. Yeah, 2004, 2005. Yep. And it's just a basic like switch to the thing. And you can see my basic bindings of 1 to 6 and then right or left. Yep. So, um, validating a built-in type, that's trivial. Validating a struct type, has anything changed here based on what we've done? Yes, here we have the problem, and I might need to figure out how to do that. I had a very complicated system back in the pre-refactor time that I might need to emulate, sadly, which was in context, I believe. Yes, I has this analyzable thing, which was basically the idea was I could most of the time look at a definition either pre being resolved or post being resolved, because most of the time I would get the information I need from there. I didn't need to actually look any further. But, and the idea of this was like, okay, if I need to actually analyze the thing to get the information, then I will do that. This allowed me to like, oh, struct that depends on one another, which is fine because, you know, like if it's struct A has a list of B and B has a list of A, then that list might be that list might be 0, and therefore it is fine to have a recursive struct thing like this. So this would allow me to go look at the definition, and even if it hasn't been resolved yet, not force the evaluation the way I am currently doing in my in this new context here, where I force the evaluation. However, currently I've in this change I've made to have better types and everything in the output, validate the type thing that I use to annotate my fields for a struct contains the full information. So even if it's an array of something, it would contain array of the type. So it would need to be able to terminate. So that means that with this system, I cannot allow recursive structs. So that means either I fix this to allow the existence of recursive structs, which means I will have to have lookups in this. So maybe here the struct info actually does not contain the types but contains a name, and this will be resolved at a later stage. Which might not be the worst idea. Like, yeah, maybe this is just base name type parameters and we break everything we've done this evening already. Maybe we break everything. Because if we keep this in direction, then to resolve a struct, I don't need the details of the fields of the struct it depends on. Therefore, it can be enough for me to be like, oh, I just need the type of this, which would be, yeah, the base name and type tree. I might do that. The downside is I will have to do lookups during the next phase rather than having the fully inline thing, and every lookup is a thing that might fail and might require an internal compiler error. Upside, I allow for cycles. I kind of want to allow for cycles. So, what does that mean? Does that mean I don't need those fields? Does that mean I can remove the struct fields and the struct info? Because if yes, I don't think my dot files are public. That's a good point. I should probably upload them somewhere. I mean, they're not great, but they work for me. Give me one sec to think. So if I reintroduce this kind of indirection for structs, the major upside is I allow something that I want to allow, which is structs that are mutually recursive. The only problem is if I allow mutually recursive structs, I will need at some point to have a mechanism in place to detect that, oh, this would result in an infinite size. It cannot be expressed, which means I will have to check that whenever I have a struct like this, its size has a potentially can converge to zero. Like I have like terminate basically, which I don't have at the moment. Okay, but if I do that, yeah, I think there are modules in Elpa and Elpa that do the same thing. I'm just using the one that I already have, but I'm fairly certain there are modules that do this. Packages, I mean. So give me one sec. I have to think about this. Because I think if I remove this, then I can probably restore the cycles that I need. And break everything we've done for a few hours, but that's fine. That's part of the game. Yeah, I'm gonna try that. So I reintroduce indirection in the type. The struct type no longer contains the fields. It no longer contains all the field information. It merely contains that's the name of the struct, and here are the type parameters we're giving it. From this, you can reconstruct something. Yeah, it's enough. It's perfectly enough. We can reconstruct the full name of the thing. We don't need the information. That breaks everything within this evening, but I think that's the best scenario. Okay. Maybe expect will have to be changed. We will see. For expect struct, I will need a struct info there, which probably will end up being a struct info validated. Let's start to make some of those changes for when I actually have to make them. Okay, and therefore in context, yeah, struct info validated. Okay. Okay. So this is fine. Let's go back to types. Let's see what else has changed. So whenever I try to validate a concrete type, validating a struct will become a lot easier. Because I might not need the full retrieve struct, because the only thing I need to do here is to check the parameters. I don't take, if I remove this, if I remove this, which is what I'm saying I want to do, the only thing I have to check is the parameter count. The mappings is not required. This is going to break everything we've done this evening. It's fine. I think it's the better option. Okay. So I think what I will need here is something retrieve struct parameters that can give me something from a struct definition that I have not validated yet. Type params. Okay. Actual params. Expected params. Length of expected params. There we go. That becomes a lot easier. Okay. That's partial type, but this logic is now the same here as well. And I need retrieve struct params, which will be in context here. And this will be a copy of this. It's going to be a bit different. Retrieve struct params. And maybe as a result, I'm going to try to do... I'm going to move those things as dedicated functions. Again, because I am going to use them in a bunch of places and look up input. Oh, I already have lookup input definition. Retrieve input definition. Perfect. Maybe attempt to validate. Attempt to validate. Do I keep that as a helper? It doesn't have a name in lookup or retrieve, which breaks a tiny bit of the logic of the thing so far. But I think it's clear enough in terms of what it's supposed to do. I'm gonna keep the name. So I'm just gonna need to. That's what it is. That's what it is. That's what it is. Except in all three cases, that's a maybe, because this thing might fail. Okay. This one validate here is when I need to have a cyclic import with the top level function, the top level module, but that's fine. And here, as a result, retrieve definition is just that. Okay. And here, this is retrieved struct parameters that will try not just to, so this is going to be basically a list of identifier, which is all I need. This will look up the remote definition, look up the local definition, attempt to, and not attempt to validate, lookup input definition. Well, I guess retrieve input definition, the type of which is not compatible with those two. So we are going to need to make a transformation of this, and that transformation will be extract. I don't need to do extract if I'm using the same thing. It's going to be a simple fmap2 of struct params of this. And I guess for input definition, that's just one fmap because this one must succeed. But in this case, that means since that one will always succeed, then that's just of this, basically. Okay. So now this one can look for something that has not been resolved yet without all the complicated mechanisms I had before. Perfect. I have two retrieve definition. Why do I have two retrieve definition? Because this is remote definition. I didn't name it properly. This is local definition. I did not name it properly. And those are lookup, not retrieve. Because those might fail, and that's fine. Retrieve, however, does not. Aha, this one does. Oh yeah, retrieve the definition, attempts to validate. Oh, maybe then I don't keep attempt to validate. Wait, where is it? Oh yeah. That's a sign I'm probably tired and should stop because I'm starting to not be consistent in my naming at all. Because this is retrieve input definition into validate the base name. Yeah, okay. And so this is retrieve. No, this is probably attempt to validate. That's probably the better name. There we go. Okay, so now I can go back to types. Here I am only retrieving the struct parameters, checking the type thing, like I do. Oh, here, however, when it's a concrete type, if I error whenever they are different. Okay. So there we go. That's validating a struct type. Validating a built-in type hasn't changed. Building a type parameter map hasn't changed. Verify type hasn't changed. All of that is the same. Okay. And now the last thing that has changed with all of this, let's go back to exp. And let's make sure that all of this still works as expected, given all of the changes that we've made. I'm just going to align this vertically, just because it's satisfying. Okay. So I am trying to validate a const path expression that must be a constant. So here, yeah, that makes sense. Trying to find a constant that the number of arguments must be 0. I wonder if that can be probably deduplicated at some point, but for now we do it here. and we retrieve the constant, which is do all of the lookups to make sure that constant has already been identified. Cycles will be rejected. Okay. Cast here, we have a type in the output. Okay. That's fine. I think here nothing has changed in terms of lookup, retrieve kind of thing. That's a function cast. It's almost the same. Field access expression for a constant. I don't do any lookups. I just check that the left-hand side is a struct expression, regardless of what type it has, and I extract that. Which reminds me that in validated, I need to check that now I have a struct type info in the struct expressions, which I think is correct. It is this thing. Yeah, okay. Okay. And here is the one that we're going to need to change, I think. So here I'm calling validate struct type. I think that's wrong. I think this function no longer exists. Oh, wait, is it a local function here? Yeah, it's the local function here. Okay. So that's validate a partial type, where I am looking for the struct type info. Okay. So here I'm not going to call that retrieve, validate. I guess I could call that validate. However, okay. Here I need to do more than that, because here I'm going to need to retrieve, to do the lookup, to retrieve the things that I am now missing from what I had before, because now I have this struct type info, but I'm going to need the struct info as well. That I guess I don't need that. Well, I do need that, but I mean, this gives me the struct type info that just contains the base name and the type arguments, the parameters. And then here I can go look for the actual proper definition, which would be a struct info. And that is, so basically that is what I'm pointing to and with the name arguments. And this would be getting the definition. And getting the definition is just a retrieve struct using the struct base name. There is only one thing here that is going to be a problem, is I think in one of those places I iterate on a thing that no longer exists. Because I had struct fields and that no longer exists. But I was only using it for this, so that's all good. Okay. So that should be the exact same. That's convenient. And so this ensure here means that basically if there are any errors as part of the type, we still try to go through the fields, and then if there are any error in like type or fields, we just bail out. And after that, we like assume that all this is found basically. And then I don't try to do any kind of probably I should do that actually. Here I do a bunch of compose and everything. I probably want to do the same thing here. I probably want to do a void ensure of or that's required there for this thing. Where I will try to report so that gives me okay, so it's gonna be a get compose of all of that. And here I'm gonna compose of try of the thing. Okay. Or maybe I will rewrite this to do a validate. It's fine. It's fine. What this does is basically it allows me to collect errors for the fields and only throw if any of them has failed, but collect more than one error before bailing out, basically. Okay. What else has changed? I think nothing else as part of this. Now, none of those things are const related, are struct related. However, here in a compare const expression, so here I am trying to compare two const expressions. I know they happen to be the same type. I have the struct type here. Wait. No, I don't check that. Ha! That's a mistake. Okay. Wait, no. I do a type matches before. I have done a type matches before. Therefore, this is only called validate binary compare const expression. That's only called in like those validate lesser something thing. Wait, no. Am I not doing a check? Oh no, I called them with validate binary expression with, which in turns. No, it doesn't check. Huh. It doesn't check that the types match. It doesn't check that the types match. Interesting. Well, I guess for validate binary int, those are checked because this is expect const int, so those are always checked. However, here, no, I don't check properly. Okay. Wait, and I have an internal compiler error here. But that's just fine. That's just a type error. Because I don't do any type match ahead of time. Let me just triple check this. An equality expression is I validate a binary expression with the validate equality constant expression function. Validate binary expression with is here. I validate a const expression E1, I validate a const expression E2, I don't check the types, and I just then call the F on it. Validate equality const expression is validate binary compare const expression with this argument. And validate binary compare const expression. Oh no, there we go. I have it right there. Expect type LHS, RHS. I know that those type match. Okay. Which I suppose makes this an internal compiler error because we have things that don't match after checking that we have things that match. Yeah, okay. So here I will need to know the name of the fields. But here I am in the context of an expression, so it's perfectly fine to do a retrieve that attempts to validate. That's all well and good. So here I can absolutely do a struct info is a result of a retrieve struct base name. And now I have the struct info. That contains, where is it? The values. Which is a bad name for it, but that's the historical name at this point. Okay. I might want to deduplicate some of that. That's a bit ugly. Like maybe I want to introduce find field that given a field name and a list of fields and a struct type. Okay, field name does this basically. Ah, something is wrong in my code somewhere. The auto indent doesn't work, which is usually a sign that something is broken. Okay. This is going to be the struct type. This is going to be the field. Fields. There we go. And now this becomes find field of the struct type of the LHS fields of the field name. So does this, except, you know, right hand side here. And now I have deduplicated this ugly thing. Okay. I wonder what I have changed to make the indentation unhappy. Probably something in here. Probably this, actually, I suppose. Now that works. So here, everything is indented correctly. So where is something that's broken? That seems to be working just fine. Ah, no, here it's broken. Okay. Aha. Case off. There we go. That is fixed now. Okay, so that fixes that. And I think that doesn't require any further change from what we have done. Okay. We are in a much better state than we started. Okay, so now I can go back to types, I suppose. Do I go back to types or... Or do I start doing... I should probably stop actually. I've been at this for 6 hours. I need to get up not too late tomorrow. I should probably stop. I'm tempted to just do validate enum because validate enum is gonna be absolutely trivial. To the point that I even wonder if it's actually even required. Yeah, I wonder if it's actually required. Oh, there is something I need to do here, however. This will give me a maybe. This needs to give me a maybe definition validated. It needs to give me something that I can try to deal with. And the reason it gives me a maybe is this might fail, but I want to recover from that failure. I want to always recover. Validate is allowed to fail on a thing and allowed to continue. I don't want to propagate the errors. I want that to be done at that level, I think. Do I? Do I? Maybe I don't. Maybe I want the caller to be able to make this decision itself. No, I need, I think, to give a maybe here because there's so much I need to do anyway. I think it's easier that way. So, this unless M no longer makes sense because this no longer returns void. And I cannot use the validated anymore. Validation. Ah, that's annoying. Since I have to return the thing, that means I have to do... No, I can still use validated. It's fine. Okay, so already validated will be the result of doing this. If already devalidated, then retrieve a lookup definition of the base name. Which is context do I have a lookup definition? I don't have a lookup definition. I have lookup remote, I have lookup local, I don't have... I guess this is a lookup local definition, by definition, since I'm attempted to validate it. So that's a lookup local definition. Otherwise, it has not been validated yet. We do the check of cyclic dependencies. We do this thing where the result is going to be a try of all of that. And maybe I will want to... Something is wrong. Something is wrong very early with this function. Why are you unhappy here? Is that a problem with the... It's just a thing of like the file needs to be reloaded. No? What's wrong? What's wrong with this syntax? Why are you unhappy? I'm in a do block. I don't have unclosed parenthesis. This is the first function. What are you unhappy about? Oh, I'll figure it out later. So here, this is the context where I have not something that's already validated. I am not currently in a cyclic definition, so I haven't errored. So in this context, I can try to, with the given context, I can attempt to do the definition. If it succeeds, oops. If it succeeds, I will need to insert it in... Oh, unless each of them does its own insertion within... Maybe each of them does its own insertion? That feels... Now that I have a shared cache, I don't think I want to do that. So I think now at this point, what I need to do... What is the thing I'm thinking of? It is in control monad extra. I want a when just, I think. When just, perfect. That's exactly what I want. When just the result, and I get a definition, I can do a few things. I can insert in the definitions for that base name. I want to insert for that base name the definition, which I suppose I don't even need to... I can write point for... I could probably write point free, but it's better to be explicit. Okay. That means validate const must now return a definition validated, which is simply a const def of, and this will probably just be the validated expression at this stage. For a struct, validate parameterized type feels correct. This is no longer required. This is gonna become purely pure of a struct def of a struct info that will contain the struct parameters and the fields. There we go. It's even simpler. Validate function type. Aha, this one is going to be a bit more tricky because likewise, I'm going to need to change. I can't just do the unless. This requires returning a maybe value overall. Aha, but maybe I can just... Nah, there's nothing to do for function definitions, I suppose. Well, no, that's not true. I will want to have the function type. So I will want to, even if the function is generic, I will want to know what the function type is. So I will always want to do a validate function type. So validate function type will not take a list of types as arguments. And when is generic, well, unless is generic, queue the instance. Which the queue there, the queue instances, is that correct? I don't think it is. No, it is. The name carries all the type information I require. But I will need to go from name to type again. That's a bit annoying. I will probably want to... Yeah, I'll probably want to rewrite this. So that's going to have to change. Yeah, okay, I'm gonna have to rewrite this queued instances thing. I'm gonna have to change the types. Okay, since I have so much to change, I'm just gonna comment this one out for now, because that's gonna be very different. So I guess the last thing I'll do is just validate enum. Which is gonna be a trivial thing of we always return pure enum info of the exact same thing, unless we decided at this stage we want to add more information, like I said. But unless we do, that's just gonna be that, basically. Okay, that's a lot of progress. It is extremely late. Tomorrow we get back. Tomorrow, Thursday, is the theoretical next stream. About compilers specifically, I don't really have... They are good resources, but everything I know about compilers, but I learned kind of on the fly. So I wish I had a better answer than like try writing a compiler, basically. I know they are good resources, I don't know which ones I would recommend. Sorry about that. Oops, validate enum there. And yeah, next stream, maybe I'll try streaming tomorrow evening, but the next scheduled stream is Thursday. And I guess we will continue with the refactor, that we have a much, much clearer direction. I'll have to figure out what to do with those function types and whether I want to try to like, I want to always delegate, I always want to delegate the instantiation of functions after having gone through all the types, or if after all I can just, since validating a function type is just that, do I want to try, I think, I think it's going to be easier to just, delegate all instantiation of functions after all the function types have been processed. So keeping the queued thing. Okay. Yeah, I'll think about it. Okay. Okay. What else? What else? What else do I have in mind in terms of changes? I've started using definition validated and a few of those, which means I will have to rewrite a bunch of validated in terms of the things in common, basically, which means in turn I will need to change AST representation to contain more branching things and make more uses of trees that grow, which is fine. That will be tomorrow, though, or again, next stream, tomorrow or Thursday. What else? What else do I have in mind of things that need to be done? Don't let Haskell intimidate you. I am using, although I try when I do my Advent of Code streams to keep the Haskell I write approachable, for this project, uh, I am not always as approachable as I would like to be. And this is a large project. So don't let this project intimidate you. Haskell is approachable if taught properly. But yeah, I'm struggling to put thoughts into words, so I think it is time to stop. And tomorrow or next time on Thursday, we resume with more of the refactor. Soon I will be at the point where I can try compiling things, which is going to be exciting because it's going to be all broken. One last thing I'm also requiring is I'm going to change completely the way error handling is done. I've made use of like primitives like try and ensure and a few of those like this. I will need to define what it is for a monad to have diagnostics. I have not done that yet. I will do that at some point. Okay, I'll stop here. Thank you everyone for tuning in, and I'll see you all next time.